And so it's time to continue with the Rust, loader, and renderer for Live2D MOC3 files. So I spent a few minutes right before the stream moving around everything in the Rust project we had. I haven't changed any code. I just moved it into different files and added the imports because it was like on one file and it was kind of a huge mess. So I have it all split up now, and we're gonna keep working on everything. Oh, wait, Cyan's bringing something. Did you make food for me? Thank you. Oh, this looks great.
Take out.
Take out? Oh.
Take out my bread.
Arigato.
Ribs. Hot.
Thank you. So it looks like I have some lunch. And,
Really hot.
I have to figure out a place to put this. Hold on. It's really hot and really liquid.
Okay.
I think I need that. I think we need to fix that table or the glass one or
There are many
something.
things we do.
Yeah.
Put it on the chair.
Put it here for now. Okay.
Oh my god.
Okay, it's fine. It's fine. We're good. Okay. They're saying hi.
Hi, chat.
All right, let me say hi to everyone, and then we will get right to it today because I want to get some things on the screen today. I want to start rendering. We had to load the whole file into memory because, like, the way the file works is it's like we declare everything like in order, so it doesn't really make sense to like only set up half of the loader. But now that the data is in memory, we don't have to actually, like go layer by layer. We can jump right to trying to render something on the screen and slowly build up everything for that. So let me say hi. Hello, Tanawa. Hello. Howdy. Hello. Tunkaski. Hello. Zedoi. Hello. Innsbijster. Hello. Boy. Hello. It's me, Newbie. Hello. Hello. Jeff. Hello. I said that. Hello. Hello. Zedoi. Hello. Aziana. Hello. Sai. Hello. Jolene looks retro. Hello. Ariane Cordy. Hello. David Jimenez. Hello. I think I said these. Hello. John Young Z. Hello, hello, Matt. This the boy. Hello, Nico. C3D. Hello, NKG. Hello, Jabbar. EAP. I think I said hi to everyone. Hello. Okay. So, I think I should probably eat first so that I don't, forget about the food for hours. But yeah, so the plan today is we have, okay, let me just switch to the screen. Let me just make sure that I am good to switch to the screen. I think we probably are. That looks fine. That looks fine. Just close some random things. Yeah, I think we're good. Okay, let me just show you. So, all I did before the stream is wait, hold on. What? What just happened? My screen is frozen. That's not supposed to be like that. Whoops. It's rare that happens. Hold on. Okay, I'm gonna go back just to be safe. Okay, that issue. I think I have two capture cards, and they decided they wanted to flip around, I think. Oh no, this is now the wrong resolution. What? Why is it 720p? Hold on. What's going on here? Oh no. I think I need to press some buttons. Hold on. Always jank, always something broken. Now where do I have this? It's always jank. Oh no, where's... Do I have a capture that's not supposed to be there? No, I should see the one. It's always... Oh, is this sign capture? No? No, it's not. Why is my capture card suddenly decided that it does not want to work? Always jank, always something broken. Okay, hold on, I'm gonna unplug and plug it back in. Actually, I'm gonna try just flipping the inputs. If I'm lucky, that'll do something. Nope, still don't have you. I have to reset those USB devices. Ah! What happened here? Yeah, as I thought, one ended up on like a USB 2.0 maybe? Yeah, I think so. Yeah. Okay. That did not help. Okay, I need to unplug and plug it back in. Ah! Jank! Always jank! There's so much dust back here too. It was blinking red, which is probably a bad thing, so let's see if this works now. Let's see. Ah, that looks better. I think we're back. I think we're back. I think we're back in business. Okay. USB. Why is USB? Why is USB always USB? Okay, here we go. Now it works. Ah. So I just split this up into files, and you can't see it because it's covered up. But yeah, I just broke it up into different files because it was getting quite messy. So not fully split up properly yet, but you know, enough that it's not one giant file with everything. So now I have the macros in one file, the crazy macros, the actual file classes in one file. Some of it needs to be moved a little bit, but this is like the actual definition for that. This part will be moved to the model file. I have the actual parsing logic here in parse.rs, and then some core types in types.rs. It's not exactly all arranged properly yet. These types will probably move to classes because they are kind of part of the file structure. But there you go. That's this is a little bit less crazy now. So yeah. So let me eat a little bit, and yeah, the plan is we have this loaded into memory now, but it's just raw. We don't really have accessors for anything. So we're gonna add some, there's basically gonna be two layers to this API. One where it hits the raw data loaded from the file directly, and then a layer above it where we implement a slightly higher level model API which removes some of the details of the MOC3 file format that we don't necessarily want to sort of declare as, canonical. Also, that will remove all the unknowns, so we only expose things we actually know about. And then the renderer is going to use that. So the first thing I will do is add some stuff to the macros so that it actually exposes these objects. It adds some like basic, get array, get item thing. And then we're going to move this part of the code, which is just the test, to model.rs, which is going to be the higher level model. And that might even move outside of the file crate eventually, but for now it's here. And actually, no, this will be the implementation of model and file. So we have core, that is the model implementation, and then the file one. So this will probably be renamed to model. And so that will move here. And then we will have a renderer talking to that. So we're not going to finish everything before moving on to the renderer. We're going to just do a couple things and see if we can get some textures on the screen and see how far we can get into showing something that looks kind of like a model. We'll see how far I get. So that's the plan. I'm going to eat a little bit and we'll get right to it. I hope I don't spill this. Is everyone doing good? Any questions? Because now is your time to ask me questions and I can answer since I'm not going to be hyper-focused on the code. So, this is good. I see. No questions? No one's saying anything in the chat. Come on. No questions is the base of the progress. Thank you. And by the way, there's 0 unsafe code in this code so far. I managed to avoid unsafe. Why did you use Sublime instead of a Rust ID? What's a Rust ID? I've always kind of used basic text editors. When I was on X, I was using Kate. I'm using Sublime on macOS now. I'm comfortable with like text editors that have some level of integration with projects, but don't try to be like full-blown IDs and stuff like that. So Sublime is basically doing the same thing Kate was doing for me in Linux. I've never heard of Rust Rover. But keep in mind that I like to have one text editor that I use for everything. I don't really want to have like, you know, per language text editors. So I would like to be comfortable with Sublime and use it for everything, because I also do Python, you know, and other things. So I don't really like having different environments for different uses. I just want to have one editor for everything. Debugging graphics on macOS. I actually haven't really used anything yet, but I do know that you can launch Metal Frame Capture without Xcode, so you don't actually need Xcode to do Metal Frame Capture. So if it comes to that, I will probably just use that. But honestly, I don't see myself really needing to do much deep debugging of the graphics. Like, there really isn't much complexity to the actual rendering part of what we're going to do. Like, it's mostly the CPU code that's just regular, you know, regular CPU debugging that's going to have to be working properly. The actual graphics output is very simple. I'll have to look at Zed. Never used it. I showed the work with a friend of mine, an artist studying computer science and facing a decision. You're an inspiration to them. Oh, consider CS. Thank you. I'm so glad to hear that. What's MOC3? MOC3 is the model file format that pretty much all 2D VTubers use, including this one right here. This model is a MOC3 model. It's the Live2D sort of export file format that I am writing an open source and fully clean room reverse engineered implementation for a renderer, because right now everyone uses the official SDK and apps that use it, and they actually don't let you use it with open source. So yeah, I'm trying to build an open source VTubing framework, SDK, something like that. Do you mind showing the dependencies you have in Cargo? I can kind of tell with you by memory. It's like, yeah, it's not much. It's 0 copy and byte order for the parsing. Then I have the basic logging stuff, paste. I need the paste macro, static assertions, and strum for some funny enum stuff. And this errors or basic errors. Not much. I think that's, I probably won't need much more. I mean, other than the actual graphics part that I'll add. So, have you decided on what graphics that you're going to use? So I think WGPU will be the production one, but I haven't decided if I want to use that now. I need to look up a WGPU example and see how easy it is to sort of get started, because I don't want to get bogged down in, you know, I know WGPU is like modern graphics style with render passes and things like that. So I just want to sort of convince myself that it's not too tedious like Vulkan is, because like I need something faster for prototyping. So I'm gonna look at some WGPU examples and download something that I can actually look at the code for, and like I just need to render meshes and textures for now. That's it. So if I can do that without too much trouble in WGPU, I think I will go for that. Otherwise, I think I'm just going to use OpenGL. So we'll see. Rough outline of what we are rendering. This isn't like traditional meshes with vertices. It is. This is only regular meshes with vertices, but there's no perspective projection. It's only in 2D. Other than that, it's just traditional meshes with vertices. The main difference is that draw order matters because you don't have a Z buffer. You can't use a Z buffer. So you have to draw everything in order, and you have to do subpasses to generate clipping masks. That's pretty much it. Other than that, it's just regular meshes and vertices. You think AI can do this kind of job? AI cannot legally do this kind of job. This is a black box project and a clean room project. Clean room requires that the project is not derived directly from the original software via reverse engineering. That software, parts of it are published on GitHub under non-open source licenses, and AI is trained on GitHub. So AI is trained on proprietary Live2D software, which means you cannot legally say that anything you do with AI is clean room. And if I were to use AI, that would actually compromise the entire, legal basis for the project. So I actually wrote about that on Twitter recently, and I wrote a policy about this that is in a file here somewhere. That's my time zone. I'm in Japan, so it's UTC +9. Almost done with the food. So eventually I would like to, for a production render, there will be both a CPU optimized deformation engine using SIMD. I don't know if I can just use, rely on auto vectorization for that or not, but we'll see. And the other one is I want to have a GPU compute-based pass for doing the deformations where that is supported. So that will come later. Like right now for testing, we're just gonna do everything on the CPU the dumb way. Eventually the render, I want it to be quite optimized. Why you chose to implement this in Rust rather than some other language? Because Rust is the pretty much the only safe systems language. So I need something that is easy to use basically that has a C API, so that C projects can import it and use this, and other programming languages can also interact with this code. So eventually there will be a C front end, like a set of exports for a C compatible API, and Rust can do that. It doesn't have a runtime that makes it hard to embed. It is very widely supported. It is stable. Basically, the only real options I have, sort of with the right level of popularity and suitability for this project is basically Rust or C or C++. And Rust is the only safe one. I like Rust. Rust can do lots of fun things. And I think writing new code in a memory unsafe language in 2026 is kind of not a very good idea. So yeah. The prototype was in Python, though. I love using Python for prototyping. Just like reverse engineering in the file format. In another universe, I would have even written a render in Python just as a test. But I think this is simple enough that it's not worth, going that far in Python, since we're going to be using Rust anyway. If you want to be in you can do burn or cargo oxide. No, just WTBU. Like, I think I'm done eating. Let me get some coffee and we'll get started. I have a couple things to mention. Is MOC3 doing something special that can be done in a vertex shader? Yes and no. Like you could write if you wanted to, you could write a vertex shader that takes in, buffers containing the MOC3 relevant structures for that, everything, and does absolutely everything for that vertex and computes the final vertex position. That is possible. That is probably not very optimal. Because there is sort of an order to rendering the model, and it's hierarchical. So here's the way it works. I can let's write a little text file. Let's show you how the eventual rendering flow would work. So the way you render a model, sort of at a given position, is first you would lock the deformer tree, and you would essentially deform every child deformer with their parent deformer position. Then you would walk you would basically walk the art mesh list, which is the actual meshes, and you would deform. You would first interpolate what did I call them? I call them pose. I think I call them pose. You would interpolate the poses into a set of vertices. Then you would deform the mesh, and then we do apply glue, and then you would render that. But actually, for glue, you need to have all the art mesh lists. So this is more like for each art mesh. And then for each glue, apply glue. So you can see that like the glue depends on the art mesh, on the final art mesh interpolated positions. The art mesh deform depends on the parent deformer and depends on the interpolated mesh. And so if you were to compute every final vertex in one vertex shader, you would be redoing a lot of work for every vertex. So this makes a lot more sense to do as a combination of CPU and GPU processing. So what I would do is I would do this first part here on the CPU, because I think the deformer tree is relatively cheap, and there are some weird corner cases that don't make sense to do on a GPU. So I would do the deformer tree in the CPU, and then I would do this in a compute shader. Because that can be launched in parallel across all the art meshes. So I would do this in a compute shader. I would do this in let me think about this for a sec. Yeah, this can be done in a compute shader in one pass. So for every vertex in the mesh, you can interpolate that vertex and then deform it with a parent deformer. That can be one shader. And then this would be a different compute launch. So after that, you launch another compute shader that just does the glue application. And that's it. And then you render the mesh. Alternatively, you could do the last pass directly in the vertex shader. If you, let me think. That would be a little bit strange though, because the way glue works. Actually, I don't know how glue works when can you glue more than two things? I actually don't know. If you can glue more than two things together, that'd be a little weird. I don't know if the Live2D lets you do that. I don't know how it works when you. I'm guessing it's not possible. So in that case, you could just map an art mesh to whatever it's glued to, and do that in the vertex shader. But I don't know if it makes sense. I guess you could do that. Could you use mesh shaders? I actually don't have much experience with mesh shaders. But as I understand it, the point of things like mesh shaders is mostly to like generate points. I'm actually not sure, but WGPU doesn't support mesh shaders though, I think. So it doesn't really help us. Yeah. Like at no point are you generating or removing vertices here. The mesh is always predetermined. You're just deforming them. Deformity sounds a bit like skeletal animation. Yeah, it kind of is. The Live2D model is basically, how do I put this? I explained it in a previous stream, but basically what you do is there's two kinds of deformers. There's either a warp deformer or a rotation deformer, which is really a fine transform deformer. And so you have a tree of deformers, and each deformer deforms the child deformer, and then the child deformer deforms the mesh. The mesh is only deformed by the child deformer, so it doesn't matter, like you collapse everything down. The mesh is not sort of recursively deformed by every deformer for every vertex. You deform the child deformer, and then that's all the information you need to deform the mesh. So normally in a model, what you would have is like a bunch of rotation, which is really affine deformers, sort of doing the bones of the model, and then a mesh deformer doing the sort of fake 3D and motion, and essentially it's like a shape key. And then you also have actual sort of shape keys for the art meshes, and it is actually a multi-dimensional interpolation. So you can have any number of parameters assigned natively to a mesh, and you have the product of all of the key points of possible poses, which is kind of crazy, and I've never heard of any other system doing something like that. So, like if you have 3 parameters, each with 5 points interpolated, then you would have 5 times 5 times 5 equals 125 separate vertex buffers, and you interpolate between, like in this case, it would be a cube. So you would interpolate 8 of those poses into the final pose. So that gets kind of crazy. So that's why I think it's also good to do it in Compute Shader, because the algorithm for this is very simple to describe in terms of, here you have an set of input buffers and a set of weights, and you just apply those weights for every vertex. But I'm not sure if it decomposes very nicely into other, other kinds of GPU work. I think I need a toothpick. I'll be right back and get some water and a toothpick. Okay, I'm back. So here's made the HL. So whatever WGPU uses, which I think is its own thing. As for UI, so if there is an editor eventually written in Rust, I am writing this so that it can have different data models for the model. And my assumption is essentially that you, like, the rendering will just take an immutable model, and you basically mutate it between frames, or you like reassign, like do like a copy and write thing where you update the model and reassign it to the render, and it will just render the new model. That's kind of the model I'm going for, with regards to mutability. So, if it's rendering in a different thread, then you could just have this cow type thing going on. If it's all in one thread, then you can just do it in line. But that's kind of the idea. So the at least with the file based implementation, there's one model object that has all the data, owns all the data, and then everything coming down from that is a basically a pointer back into the model with a lifetime. So I'm hoping that works nicely enough for what I'm trying to do. Standing desk is a little strange. Right. Okay. So I think we're gonna get started. So I just made this build again with after my my refactor, and it still loads. So now we have all this stuff going on here. Let me fix the names first, because this obviously needs to have the zeros trimmed. So I can just do a manual kind of zero. Where is this in types identifier here? So we have this part. Okay, this one. I hope you can read that, because if I make it too small, I can't fit anything. So from UTF-8 map error, and then you can say toString, and then I guess I would just do it in a separate line. So s dot just have index yeah. No, that's not what I want. S dot instead of find, yes, find. Yeah, I can just do a character. So I think just do 0. Let's say that mod as if is that all right? It needs a result. Wait, no, it should be returning option use size. I'm confused. Confused. Sorry, no, okay. Yeah, some. I'm dumb. I'm silly. I'm in non-Rust mode. Then I could say s equals s. I don't know if this works in Rust. I think you can just do s dot. You can do like a truncate or something like that. So like cut, slice. No. Split. No. Split at. But that I don't just truncate it though. Forgot. Do that. Shrink to, that's what I want. Wait, no, hold on. That's no, I want to truncate. I do have a truncate. Okay. Okay, that should work. Because that's a reference. Wait, this is toString. Why is that a reference? Oh wait, no, that's for so that's why. That's for the Oh, okay. I can just do I can just do that then and just return like that. Okay, that pause. And then I can just say let pause equals as not find 0 dot okay or is that len, and then just do this. Always ignore that. Definitely a workaround for that, I think. Looks like that's this rust. Can it be indexed by OKR? Hold on. Okay, no, this is unwrap or. There we go. Okay, that's what I want. That should do what I want. Yeah, there we go. Now we have the names properly set. Okay. A couple other things I was thinking of doing. So we have types on RS. I did want to add like a validation stuff, but honestly, I think we're going to skip that for now and worry about validation later. So let's jump right into getting a graphics canvas up and then see if we can plug it in, because that's going to be more fun. So I need something that can load PNGs and WGPU rendering texture, something like that. All right, here's the tutorial. There's an image crate. I'm probably gonna just do everything in this one crate for now and worry and split it up later just to make it easier. So, but I will create a separate module. Okay, so this is loading a surface with a render attachment. Wait, what is this doing? Okay, I don't care about this. I only care about Rust. Okay, so I need to create textures. And then you need to load it. Yeah, this is a little bit painful, but I think we can probably deal with it. Okay, and then you need a sampler and a texture view and a bind group. I think I'm okay with this if I can just copy and paste the entire thing. Give me the file, please. You okay? Yeah? What's going on?
No, I have a gum infection because I ate too spicy.
I'm so sorry.
You don't want the bread?
No, I'm kind of full. I might eat it later.
I'll take it up.
Could you give me some water though? Because I'm running out.
In the dish. You want rice?
Yes, please.
What's going on? You're getting people's file?
What? No.
Okay.
Okay, yeah, please just give me the code. Yeah, I might actually just use a separate crate then, because I do have a cargo workspace. So maybe what I should just do is just clone this and put it into a separate crate and see if we can. Yeah, let's try that because it's gonna be less painful. I do have a workspace here, so there we go. Now we can open the workspace and hopefully the analyzer stuff is doing the right thing here. It is not. What just happened? No. But it did pick up. Okay, good. Let's do that. Okay, don't save that. It keeps doing this because it doesn't. I have an issue with the NAS where the M times are like slightly different and it gets really confused. I would really like if it doesn't do that. Okay, let's just make a cargo. How do you do this? Cargo new or Yeah. So it's origami render. Yeah, you can. Okay, good. And I'm just gonna clone this thing and steal it. I hope it has a nice license. I guess MIT. Yeah, I was thinking MIT or Apache or both. I know ours is dual licensed because Apache has the patent license, and I'm kind of interested in that just sort of for CYA reasons. But Apache and MIT are compatible anyway, so like the core could be Apache and the render MIT or whatever. Okay. So what we have here is what is the texture stuff? It's under code beginner tutorial 5 textures. Okay. And I assume this is rendering some vertices. I'm not sure actually. I guess we'll find out. Gummy and put this in render. And just copy everything, I guess. If I do a cargo build here, is it gonna do the right thing? I don't need a lock in here. I don't have one. Okay, good. Okay, so that builds. I do cargo run. Interesting. Why is it a challenge? Okay, so whatever the texture thing is working. Yeah, and it has a vertex shader and the fragment shader. It has all this stuff. So it is building things. Why are there pair 5 files in here? Did it generate those or? I would like that to be part of the build process. Thank you very much. Yeah, why does it have the shaders in like 3 different versions? That's a little bit weird. Okay. Let's delete these PNGs. I don't know what the challenge is. What is the challenge? I think it's just something else. Okay, now you can swap it out. Okay, yeah, I don't care about that. Okay. So if I do, actually, I don't even know if, what are you doing? It's not the file. If I go in main here, I just realized, aren't crates supposed to be using underscores? I think a dash is not a... We have his Ireland package name, but the convert to underscores internally. Right. Okay, so it doesn't matter. Thank you!
I put some vodka in it.
I hope not. Oh, I'm gonna have it.
No, it's dirty.
It's not dirty.
It's dirty.
Fine. Okay. Yeah, there's all this boilerplate that I was trying to avoid. Like, GL would have been so much easier. But I guess we can just keep this for now. Right. There's a load from memory, from bytes, from image. Dynamic image. Okay, where's the main RS is run unwrap. libRS has all this stuff. Why is there crazy? There's too much stuff here in cargo. You don't need the challenge. How does there see dilib? I guess it's for WGPU mode or something like that. I don't really care about that right now though. Yeah, it's just and I would like a newer edition. Thank you very much. Let's clean this up into a Ayagami render. And I should be able to just throw some credits in here. I don't remember how to do Rust comments like canonically. I'm like, so it's been so long since I did some proper Rust. Is there anything in here? I guess it's just normal slashes. I mix the dots with triple slashes, yeah. I don't know if I want these in docs, but whatever. Okay.
Can I take this?
Yeah, that's yours.
Where's yours?
That's fine. I'm good.
Okay.
I'm okay. Yeah, it's just, I guess I'm supposed to use the exclamation for that kind of stuff, but, anyway, let's just do this here for now. And worry about that later and make this work. This is so annoying that there's like all this boilerplate that you have to deal with. So main RS, I guess we want to move the model loading in here. So this should be a library crate at this point, which means I'm gonna have to get rid of the main, but there's nothing here anyway. So let's move these, or move it into binaries so we can have a test binary in Ayagami. So that load model, and so then I need a libRS in here. And move the main stuff in here. Okay. Why is this thinking it's a binary? Because I also need a library. Yeah, something like this. Not file, sorry. Create file. And I need stdfs file. So how do I make it uses librs? guessing a path on this. But this one doesn't have it, so why is it? And then to be great. Okay, and then we need env in here. Okay, and then there's a private module, so it just needs to be pub. Okay, now it builds. And can I build my origami render one? Okay, so it doesn't like that. Can I copy my main thing in here? Oh no, that again. Diffuse byte, it wants this. Okay. How do I add these dependencies in a workspace? Cargo workspace. There is a way to do this. Yeah, you have to start it like that. Okay. Aha, okay, so that does work. And if I cargo run, it'll just fail because of the buffer there. Okay, good. So we have that. We have something to load the model now. We need something to we need something to deal with the. Honestly, I kind of just want to create like a boilerplate file, and then we need like a model renderer thing going on. Yeah, okay, I'm gonna leave this librs here. And I guess I'll just add a render.rs and start moving things. So subble source render.rs, render.rs. And so we're gonna need some stuff copied here from lib. And we need to be able to load textures. So render. Allow unused so it doesn't complain. And yeah, so there's vertices and stuff here that we don't care about. And indices. Okay, so a lot of that is going to go away. This struct state is similar to what I'm going to need. I need a WGPU device. I don't know how the ownership of that works. I don't know how you do that in Rust. Like, what is the... I think all those are immutable. Yeah, all those are, I think... Yeah, okay. That can be shared. However, this is, I assume there's no clone or anything like that. Oh, look, there's graphics debugger capture, so it'll actually do the, see, someone mentioned how to debug without metal. This is how you do it. You can, I think you can, you can enable the capture without Xcode running, and it'll do that. Anyway, how do you usually share? Like, should I just arc it? Because like arc would be fine. I just don't know how. Like, is there a standard for things using WGPU? Yeah, I can only use an arc. I'm just wondering, like, is there a standard type that you would use with WGPU based like middleware? Yeah, we don't need mutable for device. Yeah, what I mean is, they have those. What it means is that if you have a WGPU like middleware, is there a standard for sharing that? I mean, I guess I can just use arc. And change it later if I need to. So we're gonna need a device and we're gonna need a queue. The queue is used for loading things, but the queue, we probably don't want to have an arc on that. We only want to reference the queue when loading models and when actually submitting rendering. So I think we can just not keep a reference to that. The pipelines and stuff will need to be here though. I mean, I guess you could just pass the device in the functions to actually initialize the model, because this is not running a thread or anything, so there's no real need to, like, only the init and the like render functions need the device and queue. So maybe that's all we need. Maybe we don't need them. Yeah. And the model, I guess the model itself will have to be a reference or an arc, so that it can keep, yeah, so I'll use, and for the model is you use my Yagami file. So I really want to use the abstraction layer. The model class is model. I guess this would be file model is really here. That's really what I want. It's basically it's really file model is because this is an implementation of a model. So model should be a trait, and file model is the actual like MOC3 implementation. I don't really want to call it MOC3 model. It's more like, is there a good name for that? Like, I'm trying to avoid literally typing MOC3 anywhere, just in case there's a, you know, a need to remove that. I don't want to have it part of the API. But this is more like a, it's like a baked model or something like that. Or a, maybe I should call it bin model. Or binary model. It's a binary model. It's, it's not vertex model because there's maybe I should just call it like nah, it's like what I mean is that there's gonna be like editable models and things like that, right? Like different references for it. So this would be like a export model or something like that. It's like no, it's more like a what do you want to say is like immutable without making it so long? Like a what's a good name for this? It's not bear. Ref implies immutable, but like in Rust. But that's not really, I mean, it's immutable, but it might be mutable in the sense that you might use this to hack around the files later. It's like, it's not intended to be mutable. No, I already have view. View is, view are the structs I have for actually the, referencing the objects here. So I already have these here, the parent map view and that stuff. But this is not a model view. This is the actual model for the file. So it's like maybe cooked model. Maybe cooked model makes sense. Parsed model might make sense. Yeah, parsed model. I mean, it could apply to different file types, but yeah, parsed model kind of makes sense because it's broken up. Yeah, it's called parsed model. Let's call it parsed model. I mean, don't need this one. So then, yeah, there's probably some rename thing I can use, but, so then we have a, model render. Now, parsed model is, really the final thing. But what I really want is just to make this generic over a anything that implements the model interface, which I haven't declared yet. So I guess I might as well start creating that. So let's just say a YAML file model view, and we need a we need a type for that. And that'll be in core RS. Actually, not model view, because model is view are the structs that implement these things for the parts. The model is just the tree is just model in this case. Is it model? No, it could just be model view. But nah, it's just model. Okay. Okay. So how should this be referenced? If we are taking a reference to a model, I guess it'll be arc, because it could be shared by someone else. Model. Because the way I want to be able to update the model is you either edit it or you replace it. If you are editing it in place, then you need to have a like a mutex as part of it. But I guess if you have an editable model, you could well, do I want to put a mutex into here? I guess I could. Yeah, like it's going to be immutable in the model renderer. I'm just wondering if I want, because you might want to mutate it when you're not calling into the model renderer. And to not force a like sort of copy and write implementation. Yeah, I think something like that is fine. So let me just take an arc mutex model. Is there a possibility of failing? Yeah, I guess I need some kind of error type. What do they use for rendering for errors here? Yeah, it's just anyhow because I for the parser I do want to have all the nice all the nice types, but for the render, it's for now it's just anyhow it's gonna be much easier. If you're ever doing anything async, the mutex will be Tokyo's mutex. Yeah, I don't really know how async works with the UTPU, to be honest. Eventually, it could be like an input or something. I mean, I guess we can just replace that at some point. So let's just use this for now. It's not that difficult to replace. So when you create a new we need to have a like load model function, I guess, or replace model function or initialize model function. Well, let's worry about reloading later. So just for loading the model, we're gonna need a GPU device, which that's gonna be arc. Device. Actually, you know what? Let's just do it as a separate thing. Pub fn load model, and so then this can just be an option. Because we want to be able to reload the model if something changes without destroying all the state. And so this will be device. Let's put it in here. So for model, take a mod self. And render will take a mat self. Yeah, I guess so. So for dot model, we need to do self.model equals some model. And that'll free the previous model, obviously. And this is his result. Nothing. And so we need to load the textures. Now the model would be the model file. We also need a list of textures. Now if we assume the model textures are specified in a JSON file that will be handled at a higher level. So this would basically be a a list of bytes. Yeah, I'm not gonna bother with the JSON right now. I'm just gonna hard code the textures for the test. So as far as there's because there's the hierarchy, right? There's JSON files and there's the actual model binary. This is the binary model, right? And I really should come up with a better word for this, honestly. Maybe the higher level thing shouldn't be model. It should be I think I've seen the word puppet used before, or maybe character, or something like that. I think would make sense. Sorry, is it UID? Yeah, UID, sorry, I'm dumb. So the textures is just a list of that, and we don't need anything else for the model. The physics will come later. We'll figure out the physics. The physics, I think, will actually also be a separate structure around this. So this is just the render that just figures out parameters, renders a model. Physics is a different thing on top of that. We want this to be kind of composable, so people can use it in different ways. So this one just needs the model and the textures. So for the textures, we do this stuff, right? Now to load the anything, we need okay, so first of all, if we're reloading, you have to have like a reload model that just takes the new model, I guess. And load the textures first. Yeah, so then we need the textures in here. And I might need the substructure here because we have bind groups, and I'm not sure about that. So diffuse texture. Okay, let's put this stuff in here. So we can do iter.map. Collect. And I think that can do the right thing for this. So we already have texture in here. Let's use this directly. So then we need a device, which we have self.device. We need the queue, which would be mut queue. And that is the WGP queue, because that one is where am I? Texture from bytes queue, bytes, let's call it bytes. And I guess it wants a name for the texture, but you don't really have a name. Does it really matter? Oh, we don't even have the numerate, I guess. Do that, I guess. Okay. That seems fairly happy. So then we load the textures and then we can hopefully render something. So all right, so we can drop this diffuse texture stuff. Now what about this bind group layout? Bind group layout descriptor, binding group layout entry, binding 0, fragment, texture, filterable true, and why are there 2 bindings? Okay, I need to read the tutorial for this. Okay, it needs a sample texture and the sampler, and they are different for some reason. Okay. Okay, so then we actually need one of these for every texture. We can use the same sampler for everything though, because it's going to be the same format that we're going to need to be able to bind all the textures to render everything. Unless we can just reuse those. Hold on, bind group entry. Can we reuse that?
Yes.
Ah! Bind group. So the thing is, every mesh, so every draw call, at least the way we're doing things now, every draw call is going to be a single texture. However, do I want to... I mean, in ideally, if we are not... Ideally, it would be possible to do multiple items in one draw call, like draw arrays kind of deal, and then you would either have to group them by texture or swap out textures. But I think, honestly, especially with modern GPUs, it makes sense to just bind all the textures all the time and just use, like, you know, a either uniform or something like that to index the texture. Yeah, so for every render pass, you can change the bind group. I guess since we're setting the vertex buffer and index buffer, well, we don't necessarily have to do that. We could use a global index buffer, and actually, let me look at the WTP draw call, because that's more important. Like, what draw styles do they support? So I render pass. Yeah, draw. Okay, so vertices, instances. Yeah, sure. Okay, so we do need an index buffer. Draw index, indices, range. Yeah, okay, so that's good because we're gonna have a single index buffer for everything. Base, vertex. Yes, we need that. And so this, with a base vertex, this would draw one single primitive. So how do the instance buffers work? Indirect would be good for having the GPU sort things, but I don't think we really care about that. Now, multi-draw. It's also good for indirect. Okay, I think we can probably just use different a single draw call per mesh for now and worry about batching them later. So we just need draw indexed. The index buffer can be shared. The vertex buffer will be something we create with the output of all the deformations. It'd be nice if we could at least hold on. So how does the instancing things work? I need to remind myself how instance buffers work. That's when you draw the same data. Okay. No, that's not what I want. Yeah, because we only have one base vertex anyway. I think you would need draw indirect to batch all the draws. Now, the one thing is that in principle, you could reuse this command buffer across draws as long as none of the as long as the draw order has not changed. So that'd be a nice optimization to do eventually. But let's not worry about that for now. Okay, we're just trying to make this work. So we're just gonna use a single one, but I think I do want to use multiple textures. Do I actually? No, let's just do it separately for now and worry about that later. So back to textures and bind. Okay, so we're just gonna have a range of bind group and bind group layouts. So in that case, struct rendered. Okay, no, so hold on. The bind group. Hold on. Yeah. Okay, so you can reuse the layout and just have a separate bind group. And so we only need one layout. Actually, we just need a single one. We can initialize that at the beginning. And then the textures will be a vec of render texture, and let's call this text to be a little shorter, and BG. And so self model textures new. And so the bind group layout, we do want to create that. So then with the textures, we would create the bind group, which means for here, we would do that text equals that, and then bind group equals, so device create bind group, bind group layout, and then we need the texture, right? So text dot view and text dot sampler. I guess that works. And so then we would return a OK render texture bind group. Let's call it bind group. That, yes. And okay, so then we need shaders. That'll be in the main init. So let's grab the shader out of this. All right, so we don't need the texture, the bind group. Don't need that. Where's the shader? Shader is being used here, and then referenced from the render pipeline. I'm probably going to keep that in the file. So let's put these here. This is a shader module. Now the render pipeline is gonna do all that stuff. This primitive state is going to be a little bit interesting because We need to change the call mode on every draw call, which is a little bit painful. Though I guess you could possibly just do that in the shader by like testing something and I'm not sure actually. If we use that dynamic, I think there's dynamic stuff for... Does bind mean load into VRAM? No, bind means... it's complicated because drivers. Bind means... basically... loaded into the GPU's rendering engine to be referenced by shaders and actually drawn. But there's a thing called bindless textures, which is where you don't even bind them anymore. You just create them and the shaders can just reference them. Okay, so when this is rendering, okay, so it gets an output, it knows it has a view, and then basically we create a rendering code, and then we can do a render pass. And so this is setting the pipeline and the attachment view. The view is okay, so you can change the pipeline at least on every draw call, even though that's a little annoying. So I guess we are creating the pipeline in here. Yeah, because we're gonna have to be able to change some of the settings depending on the settings for the elements. So eventually we're gonna have to do some funny stuff if we don't switch it like dynamic pipelines. Okay, we're just gonna use this and copy and paste it for now. We're also gonna need like a pipeline key because we're gonna need to. There's not that many pipeline states we need, but we need a few. Oh, this needs the bind group layout. Okay, it needs the layout, yeah. And we need the buffers. Okay, we need all these things. Wait, where is this pipeline layout being used? Let's use in the pipeline. Okay, so so we're gonna need a vertex buffer and an index buffer. Now those will be created with the model. The index buffer will be directly, that never changes, that goes straight from the file. The vertex buffer is gonna have to be the sum total of art meshes with some like alignment or something like that. So I guess we need a option here too. Option here too. Okay, so we delete that. We don't need those. Get rid of these hard-coded things in here. I do need okay, this is U16, that's correct. Vertices are using, yeah, okay, they're doing, white block has pods now? Okay, that's useful. I didn't realize white block had this stuff. But anyway, so for the vertices, you actually need to interleave things, right? So the texture coordinates are gonna be, do we need to interleave them? We could just have separate buffers for the texture coordinates and the vertices. But then we need a different base vertex. Because if we're gonna update these using SIMD, or a compute shader or something, we don't really want to touch the texture coordinates. We kind of want those to be separate. But the way this thing, yeah, we need two buffers and they'd be indexed by the same index. Yeah, you can set multiple vertex buffers. And I guess the shader... vertex input, this has location 0, location 1. Position text coords. Yeah, so this is one descriptor. We would need to have two of them. Yeah, they're using the same buffer for both. I think we want to use separate buffers. So you want to have the vertex buffer, the text chord buffer, and the index buffer. Because actually the model also does that, and we can just copy the text chord buffer as is and never touch it. Do this because honestly it's yeah, we're not gonna create those here, and all of these can just be default. Expected Q found on MOC3. Yes, there's no end there. Oh, sorry, I'm dumb. Okay, like that. Okay, so now let's see how far are we in doing something. So we have render. We want to render into a we have a render pass. Render pass takes the attachment. Yeah, so let's leave the render pass on the parent and just have these things inside here. So we'll take the render pass render. We'll do that has a lifetime, but that's fine. And we're gonna need the queue. Actually, no. If the okay, the only problem is that we do need the queue because we need to be able to submit other render passes for masks. Which means essentially what's going to happen. No, but if we use the same texture for masks, then we can't interleave it like this. So you'd have to do multiple render passes. The problem is masks are annoying. Like, we could do them ahead of time, we could do them... If we do them in line, then, we need to run separate render passes. Which means, eventually I want to do this in subpasses, but the GPU doesn't support that. So how do I do this? I think what I want to do is accept the color attachment in this function, and then this will do the render pass. And yeah, and so that'll take the operation, and we can overwrite that for anything that is not the first one. Yeah, I think that makes sense. So then the clear color will be the clear color the first time around, and then after that we just don't clear. Yeah, it has to be like that. Okay, so let's say actually attachment. And it's basically this structure. And then, so then we do need the queue. And that'll be a render pass color attachment, which we're gonna just copy outright. Can we clone that? I'm not sure. I do need to clone that. Yeah, it does have that. Okay, good. So then we do have an encoder. The encoder can just come from the parent. Yeah, the encoder can come from the parent, and then the queue can also just come from the parent. And we don't need the queue then. We just need an encoder. Because then we can have multiple render passes. Yeah, okay, that makes sense. So then the way this is going to work is that we move this down into the function here. Let's leave a comment here. This is where we render. And so then the render pass essentially... We have to figure out the masks later, but for now we're just going to render without masks. So we have a single one. So the attachment would be a single attachment like that. let's actually do that. Attach init equals attachment.clone and attach continue is attachment.clone, and then we can say dot ops dot load equals what's that? It says load up load. Yeah, there we go. And so now, this will be attached in it. And this is a reference to an attachment list. So I guess we might as well keep the list around and avoid having to... No, this is just the call. But it's going to consume attach init. So I guess we probably want to just keep this list around. Yeah, I think we can just do that. And so then we just say some... Oh, wait, it's a reference to... Some. And so that way we don't need to recreate those too much. So this would be in the render pass. And the render pass is just gets, yeah, this is supposed to get dropped when you're done with the render pass. So I think we can just essentially, whenever we draw a mask, we would do it before this, and then we draw this. Something like that. Okay, let's... the render pipeline has to be... eventually, we need more than one because we're gonna have to use different blend states. So there's a whole thing now where we are supposed to pre-multiply the textures. I need to figure out how that is gonna work properly. How does texture RS work? Is this nice enough to pre-multiply for me? Min filter, I definitely don't want nearest here. I want linear. And I need a, like, linear for the sampler. How do I pre-multiply this? From image, RGBA, image dynamic image. Is there like a pre-multiply thing I can do in image? That would be nice. I need image buffers. Image, image ops, buffer. Okay, I need a there has to be some kind of color ops. No, grayscale did it. Nope, 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 nope. There has to be something here. Image buffer, generic image. I need something to pre-multiply. Search for alpha here. Okay, you could do map with alpha and just do it manually like that. Yeah, I guess we can just do map with alpha. No. Apply. No, I need both the alpha and F. Is it just map? No. That's that's not what I want. Pixel RGB. Okay, you can chat each channel. Image pixels much for each pixel. Yeah, something like that, right? Okay, so is that a thing? Well, it's all one image, so I guess I need to RGB8 first. Assume it's always RGBA. And image in this case. I guess you can put it in the other one actually. Where's pixels not? Image buffers? Yeah, okay. This is returning a pixel. You can get the alpha. Okay, so I can just say alpha. And then I can just say apply accept alpha. Okay. And I need the works in place one. Yeah, I do apply to each channel accept alpha. How do I do accept alpha? I guess I can just do apply map with alpha and then just do nothing for the alpha. There's a without alpha. Okay. There's there. Okay, yeah. Apply without alpha. Yes. And what is the format here? If it's RGBA 8, I need to divide. So this is, yeah. Basically that. Okay, yeah, that's what I want. Okay, that should be enough to get the textures loaded into the right format. Now render back to here. So we have the pipeline with the layout. We have 2 vertex buffers. We have the shader. Need to change the blend state. So this is going to be a little bit annoying for the pipelines because this has like add and multiply and normal blend modes, and it can have it has mask invert, but that's really just a shader setting, and it has it has the cull mode. So essentially we need to create every possible render pipeline that we might need. So I probably want a hash map of render pipelines, and then we create them on demand. See, this is why OpenGL is easier. Can you drive a hash, maybe? I'm not sure if you can drive a hash. So in here, going back to classes, we have deformer type, we need param snap type, and draw item type. Right, we don't even have any num for the blend modes because those are actually packed in a pixel thing. So we can just create something here in core for that. Pub enum blend mode normal add multiply. And copy, clone, debug, virtual EQ, I guess hash or something like that. You don't drive hash EQ. Oh, you need partial ord. Okay, partial ord. So pipeline node would have a, so you have the Ayagami file model and use Ayagami file for everything. So this would be a blend mode. Call is a bool. And what am I doing? I think that's it. And so then we can have like a get pipeline thing, right? Where we do so we need a reference to a pipeline mode, but that reference, where is this get used? Just this set pipeline. Okay, so I hope the borrow checker doesn't hate me here. And Rust hash map, is it like a get or add kind of deal? Insert and get, okay. I guess we can just do if let sum p equals self dot render pipelines dot get node return p. I don't know if the board checker's gonna like that, but we're gonna try it. Otherwise, otherwise we insert KV. Okay, so just mode and then a render pipeline here, which thankfully is just using the device. So this would have been easier with OpenGL. There's nothing like expect none. I think you could do that. Whatever. So now we need to set the right settings here. So the blend state, let blend state equals match mode dot blend node. And so we say blend mode normal. For normal, we would say color blend component. Okay, so you can do over apparently, which is kind of what we want. How does this work? Format, yeah, that's fine. Look at the docs for this. Okay, you can do replace. So it'll be pre-multiplied alpha blending. Replace alpha blending, multiplied alpha blending. What's over? Where'd over come from then? By the way, what version of WGB am I using? Probably an ancient one. What version is this? 2903. Okay, no, it is recent. So you want pre-multiplied alpha blending. But why are there two things for components? These are constants, okay, but you can probably set your own thing, right? Blend component. Yeah, okay. Oh right, no, these are everything. Okay, these are the constants in blend state. So blend of normal is pre-multiplied alpha blending. Okay. Blend mode add is a custom one. Okay, that makes more sense. And for add, since it is pre-multiplied, we basically just add, let's see, what's the add equation? For add, you would use a blend state of, sorry, a blend component. I think for the alpha, you just use the standard alpha equation. And which essentially is this blend over, which I think is the same thing as for pre-multiplied alpha blending. So blend state gives you over and over. Yeah, that makes sense. I think I'm actually not sure if add will give what it'll do for alpha actually. I never tested that in Live2D. Like, does add, I guess it should be the same as add in like an image editor. I mean, I guess we can just try that. I think. But yeah, it should change the alpha, right? As far as I know. Like if you have, if you delete everything, make sure this has alpha. So if I create like a rectangle here and I just fill it and, no, not like that. That did not work. So if I have a rectangle that is, how do I make this opacity? You can't set alpha in GIMP. I guess you just use layers for this. If I have a layer that looks like that, then I create a layer on top. And this layer is also black. So if I set the mode to add, it should do nothing except change the alpha. Okay, it doesn't change the alpha. If I make it white though, I'm actually not sure if that's changing the alpha. But I can do it by doing another square here. Yeah, it does not change the alpha. It uses the destination alpha. Okay, so add is then always supposed to be for pre-multiplied. It would just add to the color, and yeah, that makes sense because for pre-multiplied, add is always added to the color. It doesn't change the alpha. So and it's pre-multiplied, which means the operation you want to do for alpha is blend components. So actually, you could change the right mask here to just be different, I guess. Just do both, I guess. So for normal, you'd say everything blend mode. Okay, also, what about multiply? If I set this to mode multiply, yeah, that also just multiplies the color, ignores the alpha. Color rights, color. And multiply also just writes color. So the right mask looks like that. And the blend, I guess it's called a blend. So for add, we have alpha. It doesn't actually matter, but actually just keep that. What are the fields here? Source, factor, nothing. Just factor. And the operation is doesn't matter, just going to use to add. So this doesn't matter because we're replacing it. So for color then, source factor would be 1 because it's pre-multiplied, and dest factor would be 1 because we are not changing anything, and operation would be add. Actually, no, wait, hold on. The source, source is pre-multiplied. Destination is, let me think about this for a second. Destination is pre-multiplied, which means that the source factor should be 1 minus, dest alpha? No, hold on. The destination should be 1, should be dest alpha, actually. Because we are applying, yes, we are applying the, we're applying the we're brightening the destination alpha only. Actually, I'm not even sure. It depends. What GIMP is doing is dest alpha. But it might be that what you want to do is 1, actually. I'm not sure. We can test that with the... and test it later with VTube Studio. Because with this stuff out here, you could never have bloom outside the model, and I'm pretty sure that's the thing you can do. So actually, I think what you want for models is 1. I think. And then just add. Yeah, for pre-mod, that makes sense. And so then, for multiply, we would have blend component, source factor, hold on. The operation is... Well, it has to be add. This destination factor would be... source. But it's... If the alpha is 0, then you're not multiplying anything. So the, hold on. Destination is pre-multiplied, source is pre-multiplied. If the source alpha is 0, you want to do nothing. But then also the source factor... okay, hold on. So I think you do that bit in the shader. Because there's no, yeah, so multiply is used for darkening things, and you never wanted to apply outside of the destination alpha. So source factor is actually just 0 because it doesn't do anything. But you want to just multiply the destination by the source, and there's nothing else other than just source. However, the source alpha in this case would have to be pre-adjusted in the shader, so that if you have a transparent pixel, that applies the multiply less. Therefore, you essentially blend to white in the shader, and then that gives you the multiply operation that is required. Okay. Okay. So that means we either need a uniform or a separate shader for that. And I guess because we have these entry points, we can use that. So... do we need anything special for add? I think for add, we don't need any special processing in the shader. Because for add, we had destination alpha is just destination alpha, and we do have source factor 1, so that does the multiplication for us. So then we can have 3 entry points in the shader. Let's call this fs entry. Fs entry. And then in the shader, since we're here now, say fs normal, would just be texture sample. WGSO is the one we are loading, right? I'm not... yeah, it does those. And you can have fs multiply. And so this one would have var p equals texture sample, blah, blah, blah. And then we need to blend between that and white, which essentially means p dot RGB plus equals p dot 1 minus p dot a. And I don't know if that broadcasts. I think you can do this, possibly. And do return p. I'm guessing the... I don't actually know the... the syntax here, but I'm just kind of guessing. Okay, and then it's not t-diffuse. We need the... Oh, and we also need something for the masks. So when we have a mask, that has to be another pipeline mode, I think. It could be a uniform, but I'm not sure if it makes sense to make that a uniform. Yeah, let's just make it a mask. Another thing in the pipeline mode. So we have if it's normal, if it's multiply, and then we would need more, I guess. So we can match mode blend mode and mode.mask. And we also need the mask invert thing. Do I want a different shader for that? It could just be a uniform. Yeah, I think I just use a uniform for that one. So you can use 4 different shaders. Yeah, so we need a texture and a sampler. That means for AT mask. So can I choose not to map that texture? We need a bind group entry, sampler, texture view, group 0. If I want to use masking, I need Can I use multiple groups at once? Yeah, you can use multiple groups here. Yeah, so I want it as a different group. I need to take a second off to get some allergy meds because I always forget. Okay, back. So diffuse bind we test like model bind group, whatever, and we'll figure out the masking later. I don't know if you can just leave group unused. I guess we'll find out. Mask as mask. So be group 1. So you have fs normal, fs multiply, and they would have fs normal mask. And there are different ways of masking, but we're going to do this the slow way, which is going to be extra slow on Apple GPUs like this one. But it's a pretty powerful machine, so it's going to be fine. Actually, I would be surprised if VTube Studio does anything smarter than this, honestly. For optimizing masks, I really want to use features that WGPU doesn't support yet. So this is like the dumb way of doing it. Normal mask and fs multiply mask. So for normal mask, we would just say p vec4 f32 equals vector sample. And we just call this, I guess, t, not t diffuse. Let's call this t main s t model s model t model. And this model. And so then for the mask, we would just say M4 texture sample to mask. And the mask is black and white. And in this case, you do want to sample it with the texture coordinates. You actually sample this with the screen coordinates. Can you get that in the fragment shader? Okay, built-in inputs and outputs. Position. Clip position of the current vertex and the clip set coordinates. Is this both for fragment and vertex? Oh, is it fragment? Input position of the current fragment. Yes, okay. I think that's what we want. Yes. Fragment. So in this case, we sample with fp.position.xy is really. The mask is sampled in terms of the frame buffer. So position.xy. Okay, good. Why WebGL? Because this is using the Rust WGPU crate, which is a very nice API that works with different APIs and different platforms. Like it's using Metal on macOS. Okay, so now we have the mask. And I guess we can just use R. I think if you're just using a, yeah. So we would just say p.a times equals m.r and actually p.rgba even. Because it's pre-multiplied. So actually just p m.r. I don't know if that works. We'll try it. So for normal mask, same story. Return p. Now for positions, we have vertex input position and text chords at 2 locations. How do we do multiple vertex buffers? Set vertex buffer. Hey, Duffix, welcome to Team Nina. Thank you so much for joining. So buffers and ADCs, I want to do multiple buffers. So I want my text chords to be separate. How do multiple vertex buffers work? This is Deep Wiki. Okay, hold on. It's in the render pipeline. Hold on. So the render pipeline here has vertex state buffers. Okay, it gets 2 buffers. And Okay, I think I deleted the vertex buffers by accident. Hold on. Yeah, so I need these. In here somewhere. Let's leave that in there. But where's the buffer layout? This desk thing. Okay, right. Yeah, sorry. I guess this is an impl. Yes, right. Okay. Because of the struct. Right. So that's where that comes from. That's why those need to be there. Okay. So then we can put those in here. So the other thing, like vertex is just position, and there's only 2 of those. And then text chords would be a separate one. But actually, text chords are always in the model represented like this, so I don't even need the... I don't even need this as a separate struct, honestly. So I guess you just pass 2 of these, and that's it. So text chord would have an array stride of a size of text chord and step mode vertex attributes, and then there's a single attribute for the location 1, which is the texture. Offset nothing. Offset 0. And then this one's the same thing, but 2, because there's no depth. Yeah, okay, this is how it works. So then here in the pipeline, you would set... where am I? Here. Vertex desk and text chord desk. And so then we can set them separately. So, let's... yeah, so there's this whole story here for the WASM. Event loop. Here's app. App is here. App new. Create proxy stuff. Target arch proxy. What's proxy? Event loop stuff. And there's state. So where's the init? Okay, so state new is where this gets created. I think you can just do it here in state new. So let's load the model first, I guess. If we have a main RS, let's see if we can get some stuff in here. So yeah, so main RS has this instead of the lib run thing we called. I don't necessarily want to use that. let's just move the where is this? Learn WTB. Where's this code? Beginner textures. Source. Main RSS is copy. Yeah, let's just do that. Run and move this down there so we can actually put this in here and move this into the lib file. So in lib, over here, I guess we can just put this stuff in here. So let's see if this works. So we don't have an, we're gonna get the arguments. We need the textures. I think we can just load them like from the command line, make it a little easy. So we need to load the textures. The textures would just be file. You can say vec. So render is a load model. Textures is an and of U8. But this would have to be a vec of U8. Text data equals colon vec U8 equals new. And so for text file, let's mod f equals file open. Just do this real quick. Text f. And I think you can just do read all or something like that. Read to end, yeah. And I need a buffer. Okay, hold on. This Rust read entire file to bytes. There has to be something that like just reads the entire buffer. I can do read string. Okay, but not I want a string. I want read to end. Oh, okay, and that takes a mut to vec u8. Okay. Yeah. Okay, that makes sense. Let's just data vec new and then read to end. Data unwrap and text data append. Is it append? Is it append? Yeah, append data. Is it append? I'm not sure. Just push, I think. That's what I want. And so then in state, we want the renderer to be in here. So we got rid of the buffers. We don't need the indices. We don't want the pipeline. We do want those. And renderer is a create render. Actually, I think it's an import here. Oh, I have the renderer here already. Okay, so. So you create a render with the we need a device, so this needs to exist already. So let's do lower here. And create an arc on there. Give it a clone of our device so we can keep it. And that means that our own state should be arc of the GPU device. And so now that we have a render, we can load the model. So it's mot renderer dot load model. Where is this? And so we need a queue for that, which we do have. And a model, which we do have. And a list of textures. Text data. And I think that probably needs to be like cast or something like that. How broken have I... How broken is my build right now? It's pretty broken. What happened to Agami file? Oh, because I moved this to core, that's why. Classes RS. Oh no, because it's not model anymore. I think it's macros. Yeah, because the clear object is using that. This is called classes. Parsed model. I should move that somewhere else, but actually, I can probably just create an alias. And then in parse.rs, that is parsed model. Okay, now we need parse model in the renderer because we didn't name that. Actually, the model is supposed to be the core thing, which we don't declare yet. So in core is a trait model. We have that, so we don't need this one. Sorry, this is din model. Din model. Running out of water. Alright, hash map. Hash map. Okay. So in lib here we have model load. This is parsed model load. And okay, now we have some stuff here. Render cannot. I'm not found in render. In render? What do you mean? Because it needs to be pub. Let's model render. Model render. Pub. Great. And these need to be pub crate, or even just pub actually, because these are going to be public eventually. Render, pub function new, and then we need pub, oh, we do have load model. Because question mark. So then for the model, we need a arc new in there. It's an arc mutex because we might have more than one. Okay. And text data needs to be cast. So this does that, but it doesn't do the other one. How do I do that? Yeah, I guess, something like that. I think it's editor map. Yeah. Has no definite size. Hold on. Did that first. Is it that? Was that it? I think it just needed a explicit type in there. Yeah, okay, that works. Okay, getting somewhere. Okay, bind group layout. Where are we? So I need the mask bind group layout also. Now the mask doesn't need filtering. This is non-filtering. Mask bind group layout. Yeah, and this doesn't work for all the other things. I keep remembering that doesn't work. Hash map, pipeline node. Yes, I need to specify these explicitly. Now, device create packet. Yes, is device is self.device here. No, here self.device. Layout is I need to get a layout. Yeah, that needs to go in self. And so then we have both bind groups. That's bind group layout. Now I don't know if it's gonna let me not bind a texture for that and just expected pipeline cache. What? Pipeline layout. Now, actually, let me just show the diagnostics. Where is this? Oh, diagnostics panel. Easier to do it this way. So, string is not an iterator. Where am I? Yeah, that works. Why is my how to do this? And option M. Okay. Cannot find fuse texture, bind group, yeah, because we already did those. So we don't need the bind group layout, we already did those. Don't need any of these. Okay, missing fields, render. No method named alpha in mutable reference RGBA U8. Why? Image RGB8. Supposed to have an alpha? Is it because this is an old version of image, 02510? render pipeline layout in render. Self.render pipeline layout. Just pipeline layout here. No, this is the one we're already creating. So it is self, not pipeline layout. And a self shader, self config format. Wait, config format? Oh, we need to we need the format from that. That's a little bit annoying. Yeah, okay. So when we render, how does configuration happen here? Need a surface format. I guess I can just do self.surface format and then just update it. So for the default, is there some, yeah, you can just use whatever. So I guess we can just use a random format like RGB 8, unorm sRGB, which sounds like a reasonable format. And then if it changes, we invalidate all the pipelines. So in render, we would need an encoder, surface format. Does attachment have a format? We might be able to get it from the attachment. Get current texture, that's the output, that's surface texture. View. I think I lost the attachment somewhere. Anyway, attachment I might be able to dot. No, maybe not. Ah, we do have a texture format, okay. If self.surface format does not equal format, then self.surface format equals format, and then so let's call it like that. And self.render pipelines dot is a clear, right? Yeah. So just delete those. Surface format. That should work. And so then we need the attachment, which I think I lost from the example. Where was this? Ah, it just is this part, yeah. So now, we have the attachment. Now the mask could be another attachment, and then we do multiple render passes or something like that. I'll have to figure that out. But first, let's create the attachment. So this is in encoder. Okay, this can be outside the render pass. This can just be here, I think. Ooh, not uppercase. And for the clear color, we'll just do 000. So we have transparent black.
Transparent black. What's a transparent black?
A color? That doesn't work. F64. Okay.
I'm gonna go out.
Huh?
You need food?
I'm good.
Okay.
Okay,
I'll be at home center or something.
okay. I'm a little hungry actually, but
What do you want?
I don't know.
McDonald's? Mexican burger?
That might be nice actually.
I have too much bread though.
Yeah.
I can make you homemade burger.
We'll see. I might just go to convenience store later and pick something up, so.
Okay.
So self-render, render, and encoder. And then the only attachment we have. I don't have a result here. Guess I should. Okay, so now we need a pipeline. Get pipeline mode. So blend mode. Say call false, so we make sure we don't mess up. False, mask false. Blend mode is blend mode normal. Pipeline here. I bet that's not gonna work and we're gonna have to like do a different thing. Then we have the texture bind group, I think is what I called it. No. I probably need to create one. And then we need to draw stuff. Okay, I'm gonna take a very quick break. I'll be right back and we'll see if we can start drawing something. Okay, I'm back. All right, let's see what we can do. Texture bind group. This is not right. Where is my bind group? Yeah, so these are the ones that actually map the layout and the actual views to the textures. So we need to create these for every texture in the model, and then we need to figure something out for the mask texture. So for the mask texture, we're gonna need some other stuff. Well, let's just do this for now. Oh yeah, we don't have the bind group there in render texture. Sorry, it's texture.bind group. So we just have a text 0 here, and it'll be self dot sorry, textures text.bind group. And so it's comment that out for now. And see how close we are to building. Slowly getting there. Okay, device. Give me my. Where are we missing a model? First model. How do I just disable these? How do I disable this inactive code stuff? Yeah, I need this. How do I do this for Sublime? Settings JSON. Aha, it's actually the same thing, yeah. Save that. Aha, okay, that went away, good. Okay. Yeah, it needs hash. How do I get a hash? Rust, derive, hash? Is that a thing I can do? I do need to derive hash, apparently. So... And blend mode needs to derive hash then. Which is in... core. Yeah, now the... I expected that. I expected the borrow checker to complain. Wait, why is this... Hold on. Why is there an immutable borrow here? It's because of that. Right. It's this thing where like it's the same lifetime, so it doesn't. Yeah, this is not gonna work. I didn't expect this to work. Arc time. Or even just, actually, you know what? I can just have it query. I just have to make pipeline. If self something happens that has key or something like that. Contains key mode return. And then we just add it and then just move this to the other side. Okay, so this is Arc Mutex DIN model. The bind group layout is the self.texture bind group layout. Then we have, we need to do the trade bound stuff, which we can fix later. DIN model. Type annotations needed. Yeah, this is the anyhow result, but we don't even have any, right? I think there's a... Yeah, this needs a question mark here. No, this needs a question mark. No, it does have a collect. Hold on. So this should be returning this. Okay, it's because this needs a iBytes is an anyhow result of texture, or even just like this is probably gonna work. No? No. Hold on, is that not there? Oh, sorry. And so then this is complaining about not having this says it's a core result, but this is not, it's any high result, okay. Yeah, I think this needs the just the back. It just needs that. Sorry. No, we do have textures. Textures is a vector. Okay, so that should work. So why is collect complaining? Can I send it from iterator? Doesn't work. Ah, I think that worked. Yeah, okay. Okay, and now we just need the data. So now, we need to actually implement this model. So if we go, this is core, make this small, and let's go here to model.rs. And so actually, parse, I think had some stuff that needs to go there. Or is it classes? Yeah, this has to go in, it has to go in model.rs. So in model.rs, let's ignore, use super core everything, use super file, super classes, everything. Okay. And so now we need some macro magic here. Yeah, so this is pub crate and pub crate. And here also, all these should be pub crate. Okay, so all these fields in the object should be pub crate. Field ID of part fields. ID is which one? That should be all of them. Hold on, super core? Okay, so I need deref in here. So So now we need an impl model. Everything else is good. It's complaining about more private, about the types. We need those in classes here. Everything should be creating them deformer type. Actually, this should just be pub because these are going to be in a public API eventually. Pub enum parent snap type. Enum draw item type. Okay, good. And actually, this should be pub because this is eventually going to be a public API too. So now we impl the model, right? So impl model for parsed model. Okay, now the borrow checker is complaining where? Here, mutable data, why not? This is mut. And this is to be mut. And borrow q is mutable. Why not? Does q need to be mutable? Actually, I'm not sure. I think it does. Does it? No, because that wasn't mutable before. Hold on. Maybe it doesn't. If so, we can keep that. Where am I? Not this one. Ah, it doesn't need to be mutable. Okay. I think. It doesn't. Okay, good. So that means we can actually just give it in the initializer. I did not know that. So we can just say q clone. Let's q equals arc new q. Grab that. Make this into an arc. And that means that we don't need the queue anymore, so we can just say self.queue. And then for render, we don't need the queue either. Cool. Actually, we don't even need the queue in the render. We don't need to store it, but whatever. Okay, so how are we doing here? I thought I turned this off. So now we can get rid of these static arrays. And let's see how we get the model in here. So we have the model, and we need to add some stuff in here to get buffers from the model. So one obvious one is we're gonna have the index buffer. And that's just going to be a single buffer for everything. We assume that the I need to get more water. The index buffer, I guess we just do a slice at this point. And need to put these in the trait. So we have model. Let's put this at the bottom. This got indices and text chords is an F32 array. So we assume text chords are going to be one big buffer, I think, and we might want to change that eventually for models that are being edited, so they can be, so they can have multiple buffers. But for now, I think we can just have a single buffer like that. Do we want that? Actually, we might want to use some kind of you want to do it part by part, actually. And then we avoid like rebinding if it's the same one. Well, let's do it like this for now and fix it later. So indices and text chords, because that's enough to render all the textures as a test. And so then it's a self dot text chord dot values. Sorry, dot index vertex index dot values. Text chord dot values. And that does the right thing. So now we have the indices and the texture coordinates. Yeah, we'll optimize this later so we can figure out how to make it mutable. But for now, let's just do it like this. It's not even vertex. It's just this is called index buffer or something like that. It's just indices actually. Actually, it's called text chord buffer and index buffer because we probably want to make these option eventually. So if there's a global one, you have to take that option. U16 option U32, so that then we return these. And a different version of this might not have globals. So just unwrap these for now. So now we have those. And that means that here in the render, we can just grab the data from the model. This is index buffer, not vertex buffer, text chord. So we need 3. Sorry, it's vertex buffer, index buffer, and text chord buffer. So vertex buffer is actually going to be a copy of the text chord buffer initially, because we are assuming, I'm going to assume for now that, I'm going to assume for now that the, why is this not working? Option T for enum, self model, unwrap. Can just put this at the end even. I want to lock it. Okay, so yeah. I think we could just unwrap the locks and text chord buffer, unwrap. So the vertex buffer, we're going to use the same as the text chord buffer, because the assumption right now is going to be that the textures don't reuse text chords. So we can use the text chord index as the output for the vertex, processing. This is a bit of a hack, but for now it'll work. So this is index buffer. And the text chord buffer. Okay, text chord buffer, vertex buffer, index buffer. And there's a move out of model. Why? Borrow model. Hold on, what? I need to drop him, yeah. That actually builds. Okay, so now we can set the vertex buffer and the index buffer. Cannot move out. Right, as ref unwrap. So one is the text chord buffer. And then the index buffer comes from here. And so now if we render all the indices, it's gonna, okay, this is gonna be confused because it's gonna do all the art meshes at the same time. It's gonna be possibly out of sync. So it's probably gonna be something very cursed. But you know what? I can just lend it. Actually, you know what? I'm gonna move these into a single option because loaded model. Just put all these things in here. The pipelines, no, those can stay out. The surface format, no, that can stay out. But the model and the buffers can just be in here. And this makes this a little bit easier. So then you can just have so this MD, and let M equals MD dot model lock unwrap. So then this can just be MD dot vertex buffer dot slice text chord buffer dot slice and the dot index buffer dot slice That doesn't have a len. Okay. I guess I can just draw all the art meshes. So let's do an art mesh thing here. So we need a core art mesh, and let's have some basic stuff in here. So we have core. Around my core. So we have a model, pub, traits, art mesh. And so we can look at what the file has for that in classes. So we care about the, this is not ID anymore. We're gonna call these ident. Because I'm gonna use ID for a like an internal ID or something like that. I just call it UID. It could be UID instead of ID. Yeah, maybe I should use ID for because Live2D calls ID this ID. Now, but let's just give it as hold on, I'll just check that. Manual. So they have if you go to parameter palette, inspector palette. Yeah, they call it ID. So I guess we should keep that name and then just call these ID, and then we can have like a UID function or something like that. Okay, ID self. So let's just have the texture. I guess I can just be a U size. U32 to keep it the same. So you need to get like the blend mode and stuff in here. So blend, cooling, it's a bool. We would have the mask, invert mask. And what else? So we have the texture number. Texture index. Texture num. Vertex count is in U size. Should it be a U size? No, I think U32 is fine for these things because actually, what types does WGB use for like counts? It's always U32 actually. So yeah, let's use U32 for counts. Makes it a bit easier. Vertex count U32. We have a text chord offset. Should we offset or should we start text chord? It's got a text chord offset. could be index range even. Yes, it's the ops range. Let's just do it like that. And I guess it needs a visible flag. So we don't know unconfined, and we'll deal with the parts later. So now the way we implement these is some of them I want to make a macro for just pass through. So the way that would work is in model.rs we would say a core art mesh 4 mesh view. And now how do we declare these? I could just open code all this. I kind of want to make some macros though. I just have a little macro for this and make my life a little bit easier. Yeah, so I need something to get my to make the getting fields easier. For this is the whole struct of arrays and array of structs. So let's just say let's have a get here, and we would have an field. Yeah, just field, and so this will just be Oh, it needs self though. It'd be very nice to avoid the self. Because macros can't capture the self argument automatically. Okay, so we need the self for get, so we can just say actually no, I can add functions. I can make this part of the other macros. So when this declares the index types, not the index types, the view here. Yeah, I can add an impl on this. And just like a declare view getters. And that'll be on a view. Now this doesn't need to do that incremental build, so it can be the same as parse object fields. So in declare view getters, essentially what we do is You don't need the parsing pass or anything like that. What this is gonna do is import on the view. Actually, import view getters is a better name. And then actually it doesn't need to be incremental, but I do want it to have this kind of input here. Info view getters, we get object. Do I even need an object for this? No, I don't, because I'm already inside the impulse. So it can just be spec. So it'll just be self for everything. I think. So we just need the input like that. So we skip the self. Skip all these actually. Macromaxing! Macromaxing! And so, basically we just say, for a type, we just do fn field and I guess it'll be a reference because we don't necessarily want to copy the type, do we? Now all these are primitive except the identifier one, which is, well, yeah, I guess we want to return a reference because, you know, that's going to be resolved anyway. So, hopefully. So we just do, should it be mutable? No, because none of this is mutable. So let me just do self dot, we have file and index, which is not even, wait, where does this model come from? Parsed model. Oh no, because I did say model equals thing at the top. Okay, so this. Instead of file, it should be model really. Did I not declare the view for primitive? I guess primitives don't have a view because we never really need those. Self.model. Dot. Yeah, we need a paste here. Oh, I need a. I need like a function fields, which I can do here. This is the part where we don't know the... No, we should know, because all these are the same thing, just lowercase. This is like colon snake thing that happened somewhere. Where was that? This object snake, object fields. So we do object fields, and it's basically sub.model dot object snake. Just return and there. So now we have a self fields, and so then we can do in here fields dot daughter field. And this is an array, so self dot, and is it IDX is what I called it? I think so. Yeah, IDX. And return an and to that. And that means that now if this compiles, let's see. Something doesn't work here. Oh yeah, we need this for everything. So this is for the primitive type, and this is gonna be called impl view getters. And delete all these things. And then we don't need this anymore because this one doesn't do the incremental building thing, nor that. It does need that because it's a macro call. And so then for conversions, where's that dog? For conversions, we just do the mem type. Otherwise, it's the same. For option, we would return an option. Which is that if the index... Wait, no. Does this make sense? Hold on. Option. Yeah. No, those are... these are pointers. For pointers, we would want to... we're using iField for the pointers. So I guess for iField, we just do that directly because that's just going to return a I32. And we probably want to have like something that actually returns the pointer to that thing, to the proper view. So let's leave that there for now. This is the one that does the reference. As ion count. So we have I field and count field, and I field is a U32 and count field is a U32. Let's take the I field here. Count field, macro maxing. And then finally the sorry, these are the array. This one that goes in here. And this is the one that is just a single one. So just I. E32. And these all need to be pasted. Surprise. Okay, expect the U32, count 32. What happened here? Yeah, these are not AND. These are just returning the actual raw value. Alright. Deref recursion limit. That did not work. Okay, so this is model. Self model. I'll fix those later. Okay, something's not going right with this fields thing. Is it because I'm using a, hold on, what am I doing? I'm in the self fields already. Why am I doing this? This doesn't make any sense. It's just self.field. This is fields. No, it's not. This is, what am I implementing? This should be in the view. Is this in the view? No. Yes. View fields, import view getters. How are we... I'm... U32 expected, found iBlend for map. Yeah, because of that, but, so I should return an index for that particular thing, but, are those the declarations? Are the... array type as object IDX. And count as U32. Yeah, okay. So these are supposed to return a IDX, IDX and opt IDX. What's going on with the recursion limit here? I do not understand that. Reach the recursion limit while auto dereferencing. What does this mean? What does that mean? I had to get myself some water. Actually, there's some tea here I can drink. Wait, hold on. It's because I have the self-deref thing that it gets confused about. That doesn't work. It's because of that, but then how do I make it return a part form if it's actually the same thing? So that doesn't work. Then what's the right way of declaring these kinds of things? If I want to return a reference to a form, then if I just use and, it means I need to build like I don't actually have a form value anywhere because these are references. So I need a I need an input deref or some kind of like I need the traits to be using the lifetimes. I guess you could just have like form UV and form in the but then it's not import deref. mean, I guess I could have a different type, one for a ref and one for a view. And then they would essentially be the same thing. It's just the view is the one that actually has the deref implemented. Yeah, I guess I really want to just have something that returns a container to the thing that is being derefed, but isn't actually a reference. Does Rust have something like that? What implements deref and ops? Ah, there's a thin box thing. What's a thin box? Nah, that's nightly. Okay. What's ref? There has to be some. The macro maxing thing was something that chat came up with some time ago. I don't know what to do. Like, what? I think I'm just doing this wrong. Like, if I have something that can return a reference, but it could be any lifetime, and that reference isn't just a reference in the Rust sense. It has to be like a smart pointer type, but I also want it to be able to return a regular reference. And it has to be an impl deref. Do I just want to use two types? I guess I just want to use two types. Yeah, I guess I just want to use two types, really. Because I don't think there's anything in the standard library that works for this. Hello, hello, Carol. So yeah, I think we just do like view, and we have like ref, and ref it just has the view. And it's like view ref really. And then instead of sub dref, it would be just do this thing. Actually, this can just do that. It'd just be and then DF is a self-zero like that. Something like that. Okay, next put the closing delimiter. What did I mess up? Okay, and I need view needs to have a clone. Why does it need a clone? Yeah, it needs clone because of that. The ref wants a pointer, which I guess that works. Actually, it has to be self-zero. I feel like there has to be a better way of doing this, but okay. Okay, model. Let's import core. We want this the ops range. And then the third lifetime, this needs to be impl a. Okay, now we're good. Now I need to just make these definitions. And then I don't need the city macro I was trying to write there. Yeah?
The food is here.
Oh, more food?
What?
Wait, what did you order?
Chinese.
Oh, okay.
Do you hate me?
No.
It's Dragon Ball Festival, so there's a special scene.
Oh, okay.
I thought you were hungry an hour
I am. I just didn't know what you were gonna order. Okay, I think I want to do some simple macros for like converting say like pass through or something like that. And then those just basically just return the that field. So it needs an ident and needs a type. And so this would just be a copy of self dot field. And I don't know if that's gonna work because of the type stuff, but let's see. What happens if I do that? Oh, sorry, these are macro. Missing tokens in macro arguments. Oh, it's ID type, yes. ID would be a string, but we need to have some that return pass it's just good by value and by ref. And by ref.
Writing macro?
Yeah.
What magic are you trying to do?
Just avoid writing things too many times. Hey, book cannot be dereferenced. Because those are already... They're not refs. Yeah, because I didn't, those wouldn't be refs. They're just types. I know, I did say field and type. But I think it's, I need, like, I need to call this not on the impl, because it has the same things. The problem is that if I'm using the same names for everything, it gets a little bit confusing because it's actually the same thing. Do I want to have like another prefix for these for the fields or Well,
I found the wrench.
Oh, you found it? Good,
Yeah.
we can try that later. Let's just do like F. We do a paste thing here. And then we paste here too. Is that? This might be a little less painful than the... Hmm? Paste. Just paste. And then it's speed pop, okay. Okay, and then Bull needs like an into here. I guess we can just do that unconditionally. I'm surprised this isn't implemented. That kind of makes sense that you would do it. But I guess this is also by value being star into. Why is there no star now? Oh, so this is by value? It is by value. Wait, hold on. Visible? Oh, it's have two. Okay, so now only the from string. And I guess by ref would do the reborrow. So by ref would do that. And that'll do the conversion I need, I think. No? Okay, that works like that. So I guess no into for that for ref, which makes sense. I can do a reborrow. Okay, and then I just do the rest of them. So in model we had in texture blend mode. Okay, so classes. I guess it's called a texture. Oh, I had two textures there. So then blend mode, these have to be specific. So these would be render config and it's the bottom 2 bits. And I haven't specified those blend modes yet from the Python, so let's do that. So for blend mode, we want in model. So Art Mesh has blend mode, and the order is normal, additive, multiply. So I guess this can just come from the other one. So that does not need a wrapper because we're just going to use the regular one. So that blend mode. Something like that. Okay.
I push you.
Yeah, you can eat with me.
One.
Real soon. Let me see if I can get this conversion is from wrapper. From wrapper 3 and this needs the from wrapper on there. Doesn't need ort though, I think. As you size. Okay, good. And then you can just do by value for all the others. No, calling is also here. I guess that should be in classes here. I don't know if there's probably some kind of bit field thing I can use for this, but up const. The value I had was 8, I think, and that was the culling. And then the 4 is the yeah. Mask. Like that. Invert mask. Okay, good. And now we have vertex count, which is might as well use a pass through there. Text chord offset is let's do that one manually because we're using a reference. Right, this is my text chord. Start. And that field needs to be public. This macros. Index types. Okay, and we just need index range. So I probably want to add like a range thing, a nice range getter for these cases. Yeah, it's got range actually. And then then the object index and count, it'll be a range object index. And we would get the So then we need something to add U32. I can do an impl for that, for the types. Or like an offset field or something like that. Yeah, there's an impl opt reference, and I can probably just do a... no, I can't. Yeah, we need a reference like FN. I can just do this and have it here. And then I can actually just have the... No, I can't. This is the certificate map. So now I just add these to the types. So now in macros, where am I? Don't need those pub. And then this would be option U32. And then you can do like the impl add and those things. Instead of impl add, we can just have like an offset. So let's have an offset here and types. And then we can just use dot offset here. Okay, and now we just need index range, which is the same thing as range index. Indices, I guess. And I need to map this. There's no map, is there? No. Yeah, there's no like map for this, so so we just do that. Okay, there we go. And now back to the renderer. So the renderer is here. You're doing this loaded model thing, so we can drop that here. And then we have a blend mode issue. Partial ORD. Oh, you do need partial ORD for that, okay. And then we don't have the length of the index buffer. But that was just a hack. Okay. So now we have an art mesh. So then we just need to have a list of art meshes. And that's going to be another macro here. So I think I want another core thing called like collection. Where is into iterator? So if we do something like function, actually, can we do that? Let's try it. Art meshes, self, impl collection, and I think we need to declare the model types here because otherwise it's not going to make sense. So it will be like type art mesh. And we have the art mesh type built in. Yeah, that seems to work. And so, and we will also want like an index, Rust index trait. Do I want an index trait? No, I need a I need something to look them up by ID. So that's different. Actually, no, it would work with a with an index. Infiltrate is not allowed in bounds. How do you do that? can just do type tref here and have like. Self ref. And then probably need a, do we need a reference to the model? Probably not. But we do want the ID type in the art mesh itself, I think. I'm not sure. Yeah. TID and tref. It's got UID. And then this would be like T collection item or something like that. Item. Yeah, so we declare all the types like this. And so this is the self collection, self art mesh. So now the implementation of that here in model would be type collection equals item collection T. And then I need to figure out how to do the lifetimes here. Don't know if that works. Yeah, this needs a lifetime and this doesn't work. That's a winner. Bye. I was starting to wonder if this ref thing makes any sense. Okay, I'm gonna take a very quick break. I'll be right back. I'm back. How do you want to do this? This dual kind of object references thing is bothering me. Because I want this to be able to be implemented by just having like a struct and then a simple, you know, like the ref type is just a normal ref. And you implemented these traits on the struct and then it all works. But for the... For the... For the... Let's see, collection, really should have a reference to the model, I think. Yeah. So for one, collection needs to be like that. So this needs to be a reference type. The ref has to be something that derefs itself. And, okay, so then this has to have the lifetime of the collection. Fine. What about into iterator? How does the reference with the into iter item, self item? Okay, yeah, so item would be tref to get references out of an iterator. So then that should pick up the lifetime from self, which is what we want for a model. Okay. And then collection AT, collection T, what's going on here? Missing bounds, right? We need a wait, what bounds? We're self ATA, okay. I guess it does need that. Click on it. I can just do that. So that kind of makes sense. And then the issue is, if we have a type, if that always has a lifetime, if you only ever have a ref, If you only ever have a ref, then I guess you don't need a lifetime here. But then how would this work for this one? Does this work, for example? If I do it the other way around, if I have the type that takes a lifetime parameter. If I do that, can I use a type that does not have that? Like struct foo. Unsatisfied straight bound. Okay, I need if I do an impl let's do it on one of these simple ones, like part form. So if I import that, or part form, just call this like type part a part form. The art mesh with the art mesh view for this one. And it wants item for that. Okay, so it's an impl item. You would say you type PID equals U32. Ref equals art to mesh view ref. Match types. This should be construct. This art mesh view. That doesn't work. I don't know if this makes sense. I think you need to do like something like that. Does it work? No. Nah, I think don't do that there. If I just do that, I don't know if that's gonna work. If I just do that, it's probably not gonna work. Item collection. Okay, I need an item collection for this. That doesn't matter. I can just do info. What is this complaining about? Complaining about trait art meshes. I do part forms. Just as a test. So then here, a part form, it's item. And then ref in this case could just be self. Does that work? Okay, so item collection needs a reference to the model. So you would say and a phantom data, because that doesn't actually do anything. Where is that? So that's the collection. Okay, so we know what to do there. And this is missing part forms. Do there also. Need that. So you just give it an input, and it wants the index name and the intro iterator. So into iterator. Item T. And so we need some kind of iterator for the items. So what I did for this one was actually assuming it had like, yeah, it was like just taking an impl. So basically, it was just do this kind of thing. Can this infer? I wonder. No, you can't. I guess you do have to specify something here. And then yeah, there's a whole closure thing. So this needs an actual type here. So I had some object stuff going on here, I think. View, index, opt index, yeah, object. Have T object. And this is called model object. Wait, this is... Hold on, what am I doing here? Not model, sorry. Classes object. Or is that in core? Or types? That's in types, okay. Types object. Stand there. Hey, T. Tref, not found for T because it should be T object. A T IDX. Okay, so now trade bounds. Oh, what just happened there now? T object isn't satisfied. Okay, so now this iterator just needs to return a item iterator and model self.model and I is 0. Got the references. And now it doesn't like collection because we need to add the indexing part to that. So if I do index ts item UID, okay. Output index, missing output index and implementation. I can do that here actually. Output equals tref a this already takes a reference, which is yeah, this needs to do the city thing where it keeps the current ref. So we say T object item, I guess. Doesn't matter now. Just needs object. And then we just have cur and T view. So the issue with view is that some of them have some special requirements. But I guess for now we're just going to do this. T view. Just T view first or something like that. Actually, now we can just put it in here, I think. Instead of T view first, so T view. Yeah, I need some things in the macro here. So we have the view. So we have fields, and we can say next self. Actually, this can just be the iterator itself. The view is the iterator. That makes sense. So we don't need item iterator. It is just the view. Actually, the ref. Yeah, view ref. It's in this for the reference. Nah, but I want to wrap it, so let's just add an iterator here, I guess. Yeah, so we can take a view and then have like an iteration thing into it. First. Option self, view. So for the first one, we just say the lowercase stuff, self model. That's actually the self dot. It's just self dot fields. Dot count. It's not count. Should be count. Yeah, this is count. If we have at least one, then we say some self model comma index 0. That's none. And it's not self fields, it's actually model dot, yeah, this thing. Count. So we need a types view. View. Do I have a model in here? No. Where are we? In macros, we implement types view. Just say view. And it doesn't like I can speak A actually. Okay, where are we? Lots of crazy macro stuff. I don't know if this is gonna work. We're gonna try. So in macros here, we implemented view. View first model view. Okay, then view iter. Actually, this one. Honestly, some of these should just be generics. I don't even know why I'm doing this here. This needs to be here because of the model snake thing. But yeah. What? The one that was sad. I'm so sorry. Take it out. But we need to find something.
What?
No, they need to like some dongs or something. I'm so sorry.
Not spicy. Oh.
Okay.
Not on.
Okay. Put it somewhere. One of her fish was sick and we don't know why.
Can you help me? Like when you take a break.
Okay. Sorry.
Do you need to change water?
I don't know. Depends on why, but we don't know why it died. Yeah. I'm sorry. Yeah, her fish, like, she has some Medaka fish and one of them was sick and we don't know why. The water is good and everything, so.
Yeah, everybody else seems to know.
Okay. The project name, it means colored paper, is what it means. So, okay, where are we? So I think I can, these iterators, I can probably just have a generic type for that. Because we have next in there. So I can just say in types rs, or even in here in model rs. item iterator, we did have that. And so for item iterator, we would actually just have a view inside. And so into iter, return item. Oh yeah, but we need I guess you need an option in here. No, that works. And this needs to be the model for item collection, which is self model. So then we need the impl iter for and then for next, the issue is that if it's none, then we return. Yeah, how do I want to do that? Okay, I know how we're gonna do that. We want to have it initialized as none, but then we need the model, which is a problem. I think it's an enum. Why is it getting parts model? Like that. Model, okay. This lifetime stuff is gonna get confusing because the lifetime has to be the same. Can we transfer that? I need to like deconstruct self. No, this is not gonna work very well. Trying too hard. I just need to have like a get. It's not a first, just a get. Too confusing here. So that needs to be sized. And then, yeah, this is just struct again. Struct item iterator, the object. And we can just have the model in here. First model, IDXU size. Trying to make things too complicated. Not a good idea. And this is just the item iterator. Index 0. As then for next, we just say, and then I need a ref, because this is returning references. And I think that one can just be vref just as dref self-target. Yeah. I can just be a generic thing. So this doesn't need to be declared separately like that. Just the object in there. ViewRef 18 returns of 0. Yeah, okay, there's our ViewRef. I can't believe I did all this just because of that issue with the references. Okay, so now we have item iterator is T object. What's going on? Collection T. I need a bunch of bounds, probably. There's no ViewRef here. Where did I get the ref? I had the ref in here somewhere. Alright, tref is supposed to be Artemis ViewRef, which is, I think it says ViewRef. So I think I need a where here, basically. Does that work? Equality constants are not supported. Oh, you can do this. Object ref equals ViewRef. Okay, yeah, that does work. No, it's an item. That's supposed to be an item, not object. Ah, there we go. Okay, so ref equals... And then ViewRef is just on T. Okay, so now what's going on here? Type annotation is needed. Cannot satisfy object. Okay. There we go. Now it's getting somewhere, and probably the same story there. Yeah, so we need the same story here with the t object ref equals vref. Does this work? It does. Okay. And then what's going on here? Item collection is not an iterator, because it needs to be into iterator. What's going on here? Now we have the object problem. Type trait subject is not implemented for T. Because item should be no, object doesn't need to depend on item, but item needs to depend on object. So how do I provide an impl for every object? There's no way I can. How? Yeah, because otherwise you could pass in any collection for something that's foreign to this, so that doesn't make sense. So the collection needs to know about the model. Item, T item, hold on. I guess item needs to have a model in there, yeah. Okay, so if we have item model equals self, which makes sense. I always get when I have like type hierarchies like this, it always gets really confusing. This is the only issue now. Tight interest and right collection. Yeah, that's not enough because we need to somehow declare that this is only for objects. You can't have traits and traits, right? No, that doesn't work. Okay, so that fixes that. Maybe there should just be different collection types instead of one generic one. Maybe I was doing the right thing separately. Yeah. Yeah, that doesn't make any sense. There should be a separate collection type for each one instead of a generic one. Yeah, that makes more sense. So what I need as an item is a type collection. Which is A equals yeah. Should depend on collection and self. And we want this to be sized. Okay, then we drop this. And we don't need any of that anymore. Do you need that? Ambiguous associated type. Okay, not then. It's not core model. That's not helping. I need as item is what I need, sorry. That's the problem. Okay, sorry. So it's self art mesh as item collection. Okay, that's what I need, yes. Alright. Okay. And that was going on here. Missing bounds. Okay, I guess it needs this thing. I don't understand what that self A thing is, but okay. Okay, so now, fix the prototype here. Now what? Core item needs a collection. And now it doesn't, this is not an iterator, but we did implement into iterator. Because apart from is not an object, so okay. Yeah, that's fine. We don't care about this one. This be a different one. This can just be a generic iterator. What does like vec do? Do vec iter. Because this is just a test. Okay, this is std slice iter. And then that's... it needs, sorry. It needs, you know what? It's just a Vec. Nah, yeah, I would need a wrapper for that. Okay, whatever. I don't care about this one for now. I could just do... test calls. Let's just do something here for real quick. Yeah, it wants a U32 index. And then it needs the... Yeah, and so then that's an issue with, that's an issue with, where does this bound come from? Object. Because of this one? And why is it not an iterator? Because we don't have that yet. Okay, so into iterator. I'm gonna prove to myself that this actually works. And then delete all this. This yields okay, yeah, that doesn't work. Yeah, okay, I need an actual iterator of that. Because that's true for our part form, but not for everything. I can do t-core item, and then I can do ref equals t. Can do that. Maybe not. And then that lifetime parameter is not constrained. I'll just remove that. No, I can't. So can I just like phantom data this? Okay, and now this as item, let's core item. I think that kind of works. Okay, so now it needs collection in the view here. Okay, so we have this item iterator. T object is never used. There's a phantom data in there. Collection, item collection. It's not core item. Item collection. T. This call is not an iterator. Hi. Because it needs this bound, I guess. Okay, that's that. And now it's just complaining about this one because I need a bound on into iterator, I guess. Yes, I need the same bound here. Okay, now it wants art mesh view is not an object. Well, it's not an object, it's a view. So it's the object plus core item, and then ref equals view ref t, which is correct because that's here. At the top, collection A, item collection. Okay, hold on. I have to A over in scope. Hold on. I'm trying too hard to do this, and I might just give up. Okay, I have 32 types of wait. Where'd that come from? Impl object for OBJ. What do I do with macros here? Primitive would not need a view for an object. Do I need that? Because it needs the right. It needs the array types. Oh, the array types have the. Yeah, I remember I added that for something. I need to split this. Object, and let's call it, raw object. So then in macros, we can have unpull object view. No object for the primitives. We just have the index stuff. A little better now. Instead of it's right bound, I import from view item. Okay. What is going on here? Too many errors. Come on, I want to get this rendered. A little better on that. Instead of trade bound, text coord object y target. Type 63. Okay, a little better on that. So now, sweet, type found a trait. Info 4 item collection. Is this gonna work? Perm map view ref. Yeah, because that's where's that parent map ref? Yeah, that's it over here. That can just go away. That fixes that. And now just use the panel here. So it's complaining about trait bounds again. Item is not satisfied for part form view. Okay, I'm just going to delete these because these are, I'm doing artificials first anyway. So let's delete these. Item collection for collection art mesh. Okay, why is it item collection art mesh? Because I'm mixing up object. This is TVO, right? Trait item is not implemented for view. What? What it is? Because the object is actually the okay. It's view has to be core item. Okay. And now back to the iterator. Why? Because it needs the same deal here. Yeah, because item collection is taking the object. I think I'm pretty sure there's an easier way of doing this, and I'm just like, okay. So then we have item iterator for T object. Where's item coming from? From here. So then we have this type uref. Okay, almost there. Unsatisfied trait bound again. Item not invented for art mesh. What? Why? Because we need. Where did that come from? The collection needs to take. trade down T item, T view, because view has to be an item. Why is it T? Index T, okay. Is the index one wrong? I think the index one is wrong. Hold on. Index. Yeah, okay, this is wrong. We need this thing again. And you use this U32. And this is VREF. No, it says this. Okay, and now the board checker is complaining. All right, cannot for lifetime item collection. Okay, so now the lifetimes have an issue. I think I need to like restrict these lifetimes. And then we have the index is still broken. So that fixed the indexing, and now we just have this one problem left on item collection. Cannot verify lifetime prime for that. The requirements. Lifetime cannot outlive the lifetime A is defined here. But it must also be valid for lifetime B is defined here. Is that valid syntax? Okay, hold on. So in here in the item, it's supposed to be the same lifetime. Someone help me, why is this? I don't get it. Come on, I want to get this rendering today. That's not a thing. Okay, I think what we need is not this item collection thing here. I think we need to drop that. And just have the methods return an item collection. So I think we essentially want to drop this from here. And just have and just do this. So in core, we drop this collection story here. Input collection. Like that. And then, so to do this work here, I need, so for part form, we had this test call thing, which we can use, I think. And that would be, just that. And for this one, we want M collection. And what do we put in here? Sorry, self. And then item collection is just essentially that. Aha! That. Does that compile? Yeah, I think this is how it's gonna be. Okay, not a member of trait core item. What? Yes, we don't need the collection anymore. And that goes away. And this does work for this one. No, it doesn't. Okay, why doesn't it like these now? Create fiber type, Art Museum public interface can leave. Okay, because Art Mesh View has to be public now. So macros here for the view. Make that public because those will go outside. And then, of course, we also need to make the references public. And then we have Art Mesh instead of Art Mesh View. That's struct. How do we actually? I need to make it so that you can't. It doesn't really matter if you construct it, but I guess I guess maybe the view should have the object in there. Or we just make it public. Now what's the problem? Whoops, that's not what I wanted to. Okay, more of the same stuff. Huh? Semicolon? What? Types object is more private than view ref. Model is not incompatible, huh? What's that? But I kind of want these for our internal purposes only. Yeah, I don't want to make everything public. I should do something else here. I should not have object in view ref. I should have like a view in view ref. And just put the object in the view instead. Yeah, I have the view trait, so I can just do and now we flip everything around. Okay, pub crate, view ref. I guess I need a phantom thing here. Yeah. Okay. And now we have to flip this around. Assign macros here. Impl view for view. This is the object. It's gonna be like T view A. Score item ref. And then we don't need the A there, actually. Do we? No, they do need that. Yeah, okay, this is that, and then this is index. The score item UID. Okay. And so then tview get is just tget. And then vref needs to be phantom data. And then ref is vref art mesh view in this case. And we do the same thing here. Associate type view not found for T in 34. And this is just T. Okay, unsatisfied trade bound. And so then this is art mesh view. Actually, it's art mesh. That is an art mesh view. Collection art mesh view. Yes. There we go. Okay, so now we are complaining about visibility of some random stuff. VREF is reachable visibility pub. Bitrate types view is only so visibility pub crate. Yeah, because the view type needs to be public. The trait view. But this should be a private function, so this shouldn't be here. How do I hide that? Yeah, okay, so I need to basically put this view stuff in a different module. I think it's this hack where you put it in a different module. And what is this object? This is also internal, essentially. I guess we can just do it like that. Vertex index is more private than item customer view range indices. Yeah, okay, so the index methods have to be public. Those are macros. No, wait, this is for the raw object stuff. I think I'm just gonna paste this, or I guess, yeah, I don't want to do this. Or I could just merge the indices into the view. I probably could just get rid of the whole object thing, actually. Yeah, those need to be public, the indices, because we're gonna expose those. Reference is more private than the item. Yeah, okay, so reference, those can be public. But I need the... Yeah, I need... Some of these need to be private. Mm-hmm. Yeah, I do clean some of this up, but it's not too bad. Okay, let's just do this. I had to stop yak shaving this because I'm gonna take forever. Priv ref, priv opt ref. Create file types that references exist, but it's inaccessible. Okay, getting something. Brief ref. I don't know if this can be... Those straight bounds can be done, but I guess it makes sense. Can you do recursion like that? Oh no, you get cycles. Okay. Yeah, it's because it depends on you, and then that loops back. I could add offset as an extension trait like this. But... No, wait, this should work. And then I guess I can move the target in here, so we don't need to leak those. And so I move that in here. And I guess I can just put that also in private. And now it says type target cannot create private type because that is the object. What was I using target for anyway? The macros. Is it used for anything? It might not even be used. Yeah, I think it's not. Okay, so what else is left? Yeah, okay, we need to make those types public. Bool32 and U32 pair should be public because we are exposing the file interface. And then what's left here? And then I guess I can just drop object in here too. Okay, so then text chord, these are the primitives. Yeah, so the hold on, values array type. No, this is the object type. The object type is used for that index thing. Yeah, I think I need to not use those raw object IDX things here. I should just have them return the actual type. Which means instead of the view getters, it's just pass the object here too. No, that doesn't work. Hold on, what am I doing? That's dumb. I don't need to use the raw object thing. I can just use this is just another paste. It's just either type. Yeah, there we go. Okay, so now let's do the same thing as this one. Solves that. And now what's going on with Ding here? Archvedic Ding model. I guess it's just to be like a contains the generic associated art mesh. Yeah, okay, that doesn't work with Ding. What do we do about this? I think I've run into this one before too. Why no associated types? Maybe I can do something here. No, that's not gonna work. Can I just put a lifetime in parse model? Let's see if that works. No Live2D wirefragments. I don't know if this is a good idea. No, okay, I'm gonna undo this. I'm just gonna have the render be generic instead of just the din thing. Which is actually what I want anyway, because I want to optimize it, so I don't know why I'm doing din. Yeah, that doesn't make any sense. Let's keep this and get rid of the din thing. Classes. We don't need that. And then yeah, no din in wait, what happened here? Art mesh model. Do core. Yeah, okay, so we're back at the din and yeah, I didn't know I was doing that. So render should be generic over the model. So then model render here. Where's load? Enemy core, enemy file. It's not file. Where is this? Is this in types? No. Sorry, parse model. Okay, and now we have to do the draw. Whoa, that was a lot. Okay, let's see if we can actually do the iteration now. We go to render finally, and we say okay. So you begin the render pass. And we need to iterate with the model. So let's grab M. And we can do the buffers first because we don't need to change those. But we do need to change the pipeline. The bind group can stay. No, that needs to change for the text. Texture. So art mesh here is let's say just calling mask art mesh. No, mask is always false because we don't have the inversion yet. And the blend node is art mesh.blend node. So we need MD. Add these over here. And then finally, we can just use the draw index and actually have the base of the index buffer, which would be to our next index range. Okay, and now we have an issue with the borrow, but because the model is actually make pipeline only use itself for it does more stuff. Yeah, this is one of those things where the borrow checker just doesn't like this. So what I can do is I can clone this. And then I can like just put this in here. And then just put the model data here. Oh, because this is called, yeah, it's called there, sorry. The index buffer gets set here. Okay, cargo run. And now we need to get a model. And that crashed very much. Okay. Let's not print everything because that's very noisy. And we're running librs here. Okay, so what happened here? Errors. Validation error. Invalid left-hand side. Okay, yeah, shader thing. Cannot assign to swizzles. Fine. How do I turn that off? That's so annoying. Okay, how do you have position? WGPSL position. How do we get an? How do we get this input? Ah, there's a formal parameter. Okay. Built-in X. Okay. Okay, so now, entry point is invalid. Built-in position is present more than once. What? Oh, because it already has a position, sorry. We have clip position, that's what it is. I am silly. And this would be in dot clip position dot xy. Expect a bind group to be set at index 1, but we didn't do that. Yes, okay. So it wants a bind group at 1 because we didn't add the textures. Well, I think we can just do it twice. For now, because we don't have masks. It doesn't like it because of the yeah. Okay. In make pipeline, we have where they have the mask and the bind groups. There's the layout. Yeah, we need one without masks and one with masks. Mask pipeline layout, and then here okay, now we have some textures, and they're all, of course, crazy because we're not actually using the right coordinates for anything. But now we have something. We're rendering chunks of the model. So we have something on the screen at least. Now, let's see if I can do some proper vertices. Let's see how hard that is. Actually, you know what? I could probably just do it without the warp deformers. Just do all the rotation deformers. And that should give at least something vaguely similar to the model. Actually, I'm a little confused why this is like that. Because what I actually would like to see here, if I do, let's look at what the actual textures look like. I'm expecting to see essentially the atlas rendered. It is kind of there, actually. It's kind of there, but I feel like the polygons aren't where they're supposed to be. The coordinates are where they're supposed to be, and it has the three textures overlaid, I think, which is what you expect. I think the polygons are not where they're supposed to be. So let's look at that. So I feel like this art mesh index range is not doing the right thing. Okay, so we do have index numbers that make sense. We do have index numbers that make sense. Are we drawing the right primitives? It should just be triangles. At least the blending is right. Let me turn culling off. Make sure I'm not missing anything here. Okay, it doesn't really do anything. Let's only draw texture 0 so we can see if it overlaps or what's going on. Okay, so yeah, clearly something is wrong there because what if I do, sorry, equals 0, and I did that wrong. If we draw just texture 0, then we get, okay, we get this stuff. I might just be indexing the textures wrong, actually. No, it should be across and down. Yeah, that makes sense. So it's not that. That's the resize. There's something wrong with the alpha. Yeah, the alpha's not pre-multiplying, right? And some things are... Yeah, the alpha's not right. The alpha's not right, and I feel like the vertex coordinates are not where they're supposed to be. Possibly just got the coordinates wrong somewhere. Hold on. Vertex input position is supposed to be vec2. That did not change anything. Oh wait, I'm not offsetting into the. I need to set this. Artmesh.text chord offset. That's part of the problem, yeah. That looks better. At least it's kind of drawing the whole thing now. Definitely the pre-multiply didn't work. Let's see if I can fix the pre-multiply, because that's bothering me. I think this mud is just not doing... But apply without alpha should do that. Okay, what if I just set to 0? Is this gonna make it black? No, okay, so clearly it's not actually doing anything. Yeah, it's upside down. I know it's upside down. That's expected. But why is this not working? Alright, just invert. I attempted to multiply with Orpha. Okay, this did something then. Because okay, yeah. I need okay, so now it is doing something. Right, because if you don't collect the map, it doesn't do anything. Okay, yeah. So this would be as U32. Times alpha as U32. And make sure it... Okay. Okay, that fixed the pre-melt. But our mesh is still a little weird. So let's look at some art mesh that we know about. For example, the chair was one of the last things in the list. I had some Python shenanigans going on. Like 129, 130, and 131, those are the wings, for example. So you can do that. But I don't remember the names for those, and I need to iterate with... I guess I can just use enumerate here. So 129 to 131. This shouldn't be into iter, should be iter, right? Yeah. Okay, that does not work at all. So clearly something is broken. Hold on. The text chord offset and all that stuff. I might have like an off by 2 thing going on. Right, vertex count is in terms of it's in terms of individual coordinates, not pairs. So I actually need to divide by 2 the vertex offset. And that actually should be done here in the model map. Yeah. No, index range is fine. Those are singles, but the text start is divided by 0, by 2. Aha! There we go. Now we have a wing. So that was the problem. So now we can get rid of this guard. And that makes sense. Now we have all the parts. And those are clearly being rendered correctly. Just in the wrong place. So, let's see if we can just kind of hack this around a little bit. So I need to essentially just have a little transform. What's the easiest way to do that? The WTB examples probably have something. And then I'm just gonna apply the let's take the let's figure out I need a little more I need just a few more things here to get the right mesh. So first, before going to deformers, I need to get the actual mesh data from the art mesh. Which means I need to actually upload some data. How would we do that? Yeah, you can do map. So let's just first have a separate function here that is called something like calculate. So then I need to have this UID thing going on with the art mesh. Let's put that in core because I need a UID. We know those are U32s. And let's require that UID is hashable. So for any item, we need to be able to get the UID. So I need to do an impl item in the macros. Actually, that's not even the macros yet. It's just here. In model. And it's itself.index is all that is. So now we can look up the UID and the art meshes, and so then we need a hash map of the art mesh state or something like that. This could be a loaded model. Actually, I need to make sure we can get like default in here. You want to wrap a hash map. It's either this or either this or extend it with a trait. So I want to extend it with a trait. If I use a trait and just put it on hash map, I could just have like a get default or something like that. Yeah, maybe I can just use a trait. Trait item state. Let's see. What does it get? Some hash map. Contains key, I guess. Or I can just say, yeah, contains key. If not, self contains key T. Self dot insert IDX. Default. So for calculate, and just do something there. So we need std hash. Art mesh state. Where is this? That needs that because we have a lifetime. The UID. Can I just do that, please? No. Oh, no. Oh, no. Now this is a problem. Wait, I can say static, can't I? Ambiguous associated type T as item. Sorry, not T as item. Or I just do this. Okay, yeah, that works. And then we should put those in the bound here too for UID. Okay, there we go. And then art mesh states in here. Looks like you put these in another something. And we can even have these all separate, maybe. Yeah. So, we need to calculate all the forms. So we need buffer. I don't know if we want to do a no, this is like async. Okay, that's not what I want. Okay, how do we do? Let's see. Let's go to the learn WGPU thing again, because there has to be some way of doing models. How do I, like, buffers and indices? I could just create a new buffer, but that seems a little bit, dumb. Maybe that's the easiest way to do it, honestly. Maybe you should just do that. Yeah, actually, you know what? We're just gonna do that. We're just gonna thrash the buffers. Because that is actually probably more efficient than... Yeah, it should actually be more efficient because we create a new buffer every time. So we create a vertex buffer. And we need a an array, so... Actually, I think I'm going to need to use a vec of F32s like that because all the mutations I'm going to do are kind of... No, I guess I do need XY. Actually, we can just do the vec new. And resize it. Resize width. New len is mtext chord buffer len. Sorry. Where's text chord buffer? Yeah, this really should be returning double thing, but wait, len is private? What? Oh, sorry. Unwrap len divided by 2. What's going on here? Okay, so we have some vertex buffer and we can just say then cast slice. So it'll give us all zeros. No, I need it towards that. Oh, we have the struct text chord anyway. Okay, so this is struct vertex is what we want. So let's use it. Okay, we don't need that anymore. And derive a default for state. Wait, why doesn't it have... this needs a default, but... Huh? I'm still confused. Why is this default not working? Why would it need T default? The hash map doesn't, there's no instantiation for default here. I'm so confused. Drive macro is quirky. Okay, so it's just drive being silly then. So now we are rendering. Let's get the state in there. So we need to figure out how to get. We first need to get a like idle pose vertex map. So to do that, it's basically just go and calculate here vertex buffer. So for every art mesh. We need to be able to get the the other collections, the forms. So let's get the forms. Classes, art mesh. Yeah, basically this. We need pair maps and forms, same as we did in part there. And in this case, the target would be an art mesh form. So that gives me the pair maps and the form. So for form, in let's go back here in model form. Where's the part stuff? Oh, yeah, this is the test here. So where was that? So you basically need a T-get. So I need to move these to macros later, but for now, when I've been doing this, it's not mesh form, it's just form and trying too hard again. Get self model and in the model we have art mesh in classes. So that's an array. And I actually should just implement this in the macro for these in the fields. I found range. Okay, put if in. The only thing is that we don't have views for the text chords and stuff like that. So we would need to know if this is a view or not. Okay, let's deal with that later. Oh, whoa. I could add something for the primitives, I guess. Just add another test here. I would like call it like prim for primitives. Or even I could even just abuse the like pointer syntax. Like that. Yeah. It's a little weird, but I think we can work with that. Expecting funked. What happened here? Not allowed for TY fragments. Okay. Oh, I just put it in the wrong place. 222. Oh, what happened with that? Why is that not compiling? Am I missing something? Upload new getters. Or I could just do it differently and is it because of what's the problem here? Where is this expanding? It's expanding in the oh, it's a syntax problem, right? It just doesn't like this syntax. I could just have 2 ands. Yeah, you know, let's just do that. Double and for objects and single and for single and for primitives. And that way we can even have the this trick here. And avoid having to duplicate this one. That did not work. Macros. Daughter and that looks like it's not happy. Okay, let's just not do that. I guess it does want that. That might actually work now. So let's just do this. That's better. And now, and why is model not... Hold on, let's fix that one first. Oh, now it works? But it doesn't. Okay, that does work. Okay, art mesh form, where we were with that. Types art mesh form. It needs a art mesh form view. That's what I want, actually. And I guess this should be a option. And this needs to be a ref. Let's have vref new in here. Almost done with this. Where's vref? Types. I'm gonna have a get ref in here to make it a little easier. Let's go get ref. And get ref. So then in model we can do just get ref. So we probably want a macro for this one. Item. Declare item. So for parent maps, we would need an iterator that actually has an end. So I probably want to have an item iterator. I want to have this iterator here. It should have a count. So for limit, we would just get actually this can see the max. Because size. Because it's gonna check here anyway. So then I can return iterators that have sub collections. Let's have a by ref, by value. Child collection. And it's actually parent map sets. No, it's a parent map set, sorry. Where's that coming from? Okay, I'll leave this there because we don't have it yet. I guess this would be a different iterator. We would need a, we have a paramap set. In those gets, should really be using should be using indices like that. So instead of a U size, what you really want is a I know that doesn't use as yet because we don't you don't have the super type in there. No, we do have the type object. Let's use object index there.
Hi.
Yeah. I see.
I'm making a chocolate cake.
I'm looking forward to that. My part found U size. This is in, well, not that. I'll fix it later. Okay. guess item collection really should be the one that has the limits too. Where's the fields for this? It's supposed to be art mesh, I think. No? But it does have it. Is it because I did not declare the... Is there pop creep count? Anyway, let's go back. So for parent maps, what I basically want is a sub-slice of the collection. Essentially, we return this. But in this case, it would be a set of parent maps, which is a it's a weird thing with the iterator actually. So this is different. At the forms though, we can return like this. Actually, do that later. Parent maps. So we have the parent map set view. We want these to be using those collections, I guess. I'm getting tired. Here in macros for the case where we have a non-primitive with two ands, you can say just our field even. views. Let's see. Let's just say item collection new and pass these things here. Hello.
I'm trying to not waste the chocolate.
Okay, I eat some.
Ow.
Huh?
Ow.
Just do that.
Those chocolate. Those are important documents.
That's fine. It's not that broken. Item collection. Okay, so we need to import that. I guess item collection should be in types, not here. I guess this needs to be pub. And here in types, create new. Okay. So now we need to declare the art mesh form and fix whatever's going on here. T get ref new. Just say get ref. And it's not T-ref, it would be T, yeah, and then it needs these. IDX. And then I guess I just need to import the pref ref. No, it should be there. Okay, so now the macros for the other stuff. I'm not sure what's going on with that. Oh, wait, this is wrong. Let's remove that for now. Okay, so now the form, you have to do this calculation with the parent maps, which means we need the parent map set. So let's do that later. Parent maps into iterator, parent map. Okay, what's going on here? So why is that not implemented properly? Pair map set view has pair map set view. No. Pair map set has a list of refs. We can probably do something for the refs there. In macros. Yeah, we have this views one, right? Views refs. Okay, let's just unwrap that. Okay, so item collection doesn't have iter into iter. And we need the trait bound for that. I wonder if we can kind of remove that. If I do the into iterator, if I remove that from this. Okay, let's go back to the model and art mesh form view. Okay, getting close. Why don't we have the privref and privotref? This is called types. Because of that? No. Because these are super reference. I need like ref here and priv of ref, I guess. Yeah, okay, that works. And then this needs to be converted as U32. Because I also use U32 for these. Hold on, its item collection is start should be limit. Item collection. Okay, and now it's just complaining about the parent maps. So for parent maps, what we need to do is first enable the deref thing there. Does that work or does it complain? No, why does it say on non-field parent map set? I don't get that. But this one worked. It doesn't work for single items. I have a typo somewhere here in the non-array case. It's this one. Okay, parse. Oh, it's parse frame is where it's broken. Okay. It's this thing, right? It's the one I forgot. Okay, so now, yes. Now we just have this one thing to do. So, views refs. So this should now be able to just return a self dot. Actually, let's replace that. Field views and field view. And so there's no range. And this is not item collection, it's just a view. So for view, we do view new. Like that. And we unwrap that because that should always be correct. Okay, there we go. So now we can say so now we have this iterator, and then we can do map. And for each ref, we get the pair map for that, which now is easy because we have the ref. So we can just say in macros, in classes, sorry, where we have the pair map set. Now we have these, so we can actually get some nice typing going on here. Okay, that one is... need to figure that one out later. And so then we can say a.map_view, and that's the parent map. And so now why doesn't it work? The ref not implemented for parent map view ref. So we need to get a ref for the view. We can just have an into ref thing going on here, I think. Okay, so now we have an issue with the borrowing stuff. Ours borrowed here. Map view into ref. So the issue is we need to essentially clone that. But now the problem is that we have we don't have a way to return the state here.
Chibi,
Yeah?
eat that so I can put it in the dishwasher.
Okay. Let me finish. I'd like to finish.
Why are you finished?
Trying to draw something on the screen that's not a mess.
Show me.
We're working on the code.
Teach me.
Okay, so I think this iterator stuff may not be the best option here. Let's actually just have paramap set and have that be a view. No, I don't want to expose paramap sets into the caller here.
Usha. Am I sleeping with you today?
Hopefully.
Hopefully.
Yeah.
Eat your bread.
I'll eat it. Let me finish. Could I collect this or something like that? Because into iterator, if it's an into iterator that returns an impl deref, that means I could, in theory, collect this into a vec of pair maps.
Dame, dame, dame. Dame, dame.
Mm-hmm. Has to be into iter. So pair map view ref. No, sorry, it's ref. Does this work? Okay, that does work. So if I can manage to populate this, I in PMS must use Huh, that does work. So it's an issue with the lifetimes. Actually, VMA should be self pair map set view. Pair map view, pair map review. Hold on, where are we? Assets. I.map. Yeah, so that's where we get the map view. Yeah, okay, BAP doesn't really work here. Yeah, it's just it's basically this. It's ref. Yeah, this is kind of a special case, really. Something like that. Yeah. And then I guess we can probably just do that. Yeah, we can do that. Okay. Yeah, there's something weird with the lifetimes going on here that I don't know how to fix, but we're just gonna do this. Okay, so this will give us the pair maps, finally. And then we want to find the 0th key point and look up those forms. So this needs to get the index. So this is another thing we need to do. We need to do this story thing here. So it's dot refs views dot into iter enumerate, and now we need to calculate this index. So this index gets calculated as let mat index equals 0. Let mat step equals 1. And then we need to kind of assert. I need like a zipping thing here, I guess. Index plus equals step times indices. So indices I. There's no view for this one? We have range, yeah. And then we have paramap reference. Map view dots. And then we need count key points. There we go. And so then we get the form. And does this indexing thing work? I guess it shouldn't be an option because it should always exist. It's been nice. Let's put an option in there. We can say if indices I is greater than count equals that count, then just return none. I guess it should really be U32. So we're using U32 for all the indices anyway. View ref does not implement the copy trait. We clone it though. Expected average view. Wait, what? No? I'm confused. Art mesh form? Ah, okay, so now there's a problem with the types not being associated properly. Oh no, because it needs to be a ref, that's why, sorry. There we go. Does this work, actually? Maybe all I needed was a clone. No, that doesn't work. Does that work? Okay, now I'm gonna stop messing with this. Okay, so now we are. Okay, so type and macros. Into iter, item iterator cannot leak private type. Oh yeah. Okay, so now that was a pain, but now we have some nice primitives going on, and this is starting to be a little cleaner. So now we grab the parent maps, and then we pick out the idle form. So in the renderer here, and we need to add some form extensions too. So we have let's get at least the parts rendered like on the screen properly. So load model, reload model. There we in calculate. So for each art mesh, pair maps. And so we need to grab the parent map So what are the classes there? Just a set of key points. And the set of key points is just a set of F32s. It's actually for macros for the primitive ones. I think we can just say return a slice. Or even just say field here. And yeah, say slice. Oh, is it snake or what was that? Something like that. No value in part form field, so that's because we have okay, so now we have vertex index found reference U16. Because we don't have the right types for these. I guess what we can do is in the primitive declaration, we can declare a type, and then use that in the others. So here in declare primitive, we can say array type dollar type, and we can just say type dollar type. And then we can just use it in the other one. Wait, that's not the same thing. Okay, so then where's warp form? Key point view, no key point view. Why no key point view? Because key point is a primitive? Yes. Okay, getting there. Okay, and now we have the this part, so we can implement it in model. That's really easy now. We can just say key points self dot key point size. There we go. Now that gives us all the key points, and then now we only need to add the art mesh. Let's move this down. Have parent map view in there. We want to have a parent map view. Okay. So in render, we need to find the key point that is 0. And there should be an easy way of doing that. Rest size type. I think there's a there's probably a find or something here. Like iter position. Okay, so we do find that iter position predicate p. Did my SB break or what? I think this does work for zeros. Which, I mean, I guess we could just, I guess we could do the whole map thing here. I think SB broke. Let's try restarting Sublime. Okay. So we'll go on this. Actually, we don't even need, and ideally we would look for the parameters actually and use the default state, but we're just looking for zeros for now. Let's put this neutral indices. And and then we need to find the form for that. Okay. Gets us the form, and then we just need to finally add the art mesh form thing here, trait. So really just need I guess vertices. And so for vertices, we would say self dot. We have an I start vertex, but we don't have a count. because the count comes from the art mesh. So this is a case where ideally we want this view to have some special information that we don't have. But since we don't have that, let's for now just do it kind of manually and look at the start vertex and just say self.model dot vertex chord dot values and just do that. But I need a transmute cast thing in here. And yeah, we need this transmute thing. And where was this? What's the transmute thing I was doing here? Was this in parse? It's transmute ref. There we go. So now we can get the vertices, and then from renderer we just go and get the vertices. Vertex count. Mm-hmm. Okay, yeah. As your size. Size is not implemented for... Right, because we need that. And then we need to copy that to the BTX. There's some cast things going on here, right? White mount cast slice, yeah, we can use that. Is there a replace or something like that? Or can we just do slice assignment? Is that a thing that does work? Huh? Render vertex is not sized? How is that not sized? It's dot position. Okay, I need to transmute that, but that's fine. It needs like some no init thing or something like that. Byte mark, no uninit. Whatever, I'll just copy. Something like that. Okay, now let's see what happens. Evaluation panicked. Incompatible types. So that transmute did not work. Did it try transmute ref? Yeah, oh, because that's because it's not a Right. I need like a type vertex or something like that. Let's get some derive in here. It needs immutable, I guess. Try for transmute mat. That doesn't work. Oh, I guess it could just be something like that. So the problem is the alignment. So I guess what I really need is to change the way that vec works to actually use a different line. Okay, that's just kind of annoying. Okay. Wait, why is key points? I'm dumb. What am I doing here with key points vertex? What? No, I'm silly. What am I doing? Wrong place. I'm silly. This needs to go in vertices, not key points. How am I doing? Okay, I'm clearly tired. I'm clearly very tired. Okay, it's this one. But it still does not work because of the size alignment stuff. Yeah, I guess this needs to be converted. We basically have to assume everything's always aligned, and I convert the vec to that. Okay, now not today. We're not fixing this today. We'll figure this out tomorrow. For now, we are just going to declare this as classes. Where am I? And model here. Vertices. We are just going to return it as an array and figure this out later. Okay, render, and then vertices be and then this V doesn't work because I need them to I need to double them up. Is it gonna work? Are we gonna get the parts? They should all be overlapping each other, but okay, that didn't work. Where did it panic? Where do we panic? Oh, not yet implemented. Which one is not implemented? This is the index. Oh, it's index. It's index for what? Oh yeah, we didn't implement index for item collection. That needs to go here in core, not in model. Not this one. This one. So not model. Actually, it would just be the view, which is no, what? Index is Unity is supposed to be U32 for everything. Yeah, so I am confused. Oh, sorry. This whole thing needs to be right. That. And now the problem is that we cannot return a temporary, so that doesn't work. I can't index. Because index always returns a reference. Yeah, okay, that doesn't work. Okay, so we cannot use the index trait for this. So I guess I just move this into the item collection thing then and remove the bound on index. Remove that call thing, and in core remove the collection, the index bound, because that doesn't work. Okay, there we go. Now we have that. And so then in forms views index, that doesn't work. There should be two different functions actually. It should be an index that takes like a usize and a get that gets a UID. And in this case, we can just say insert. So let's start equals 0 because we should never be using get on a sub collection. I can probably split that into a separate type later. So let's now start at 0. And now, okay, we can drop this this part form stuff. That was just a test anyway. I think we can delete this now. Okay, and now it panics in. Oh, self start 0. Why? Oh, because index calls get. Yeah, okay, that we have this backwards. Okay, that didn't do what I want. Because everything's still in the same place. Probably because I didn't upload the buffer. So we have a vertex buffer, and now we need to just overwrite it. Self. Need the MD stuff. Hey, now that looks a little bit better. That looks like a bunch of things on top of each other. That's not everything is right. I don't know what happened with the background there, but some of those are definitely parts that look like they are somewhat reasonable. Okay, I think I'm gonna call it a day. Next time, we just have to plug in the deformers and actually make the parts show up in the right place. Yeah, we're not doing draw order or anything yet. Everything is random. So, but I'm just slowly building up to the model making sense. To actually put this in the right place, we need the deformers, and for that we need to do some math and change the vertex shader. And it's getting late, so I'm not going to do that now. So, this is what we have. All right, thank you everyone for coming. Getting there. Actually, it's kind of interesting. Like some of them have, you can see that the hair has the offset, like baked into the textures. Like some of the hair for some reason, but not everything. So, yeah. All right. As a plan for the next stream, just put the things in the right place so it actually shows the model. But yeah, we're getting somewhere. I want to fix a few ugly things like this indexing by half coordinate mess that we have there. There's a few things that need to be fixed, but yeah, getting somewhere. All right, thank you everyone for coming. I'll see you all next time. Bye.